All right. So first question for you. When did AWS release their first service for public consumption? Their first like AWS service. Does anyone know?
2003.
2003 is good. Actually, that's really close. Not right on it, but close. Anybody else want to take a shot?
2004.
2004. Getting warmer. Of course, we could keep going, right? So good, Daniel. So basically, AWS released their first service, SQS. It's actually not S3, which even some Amazonians get that kind of weird. Is that it was actually SQS, the simple queuing service, and S3 were released in 2006. So cloud is now, in a sense, because that kind of like started everybody on the rush, right? So you got Microsoft involved, and now we got Google involved, and the next thing you know, IBM is involved, and then Oracle's involved, and next thing everybody's got a cloud everywhere, right? So the reason this started is because Amazon published this for a service, and you're like, well, what made that so special? Didn't we have other people's servers before? Because that's the joke, right, about cloud, is that it's just other people's servers, right? And what we're going to find out is that there's a couple of models in the industry about how cloud computing is perceived, and then what was the big distinction? Like, what was the thing that made AWS all of a sudden put them on the map and made everybody in a rush to chase them around services? Well, this is what we're going to talk about. So we're going to talk about the 3 deployment models for cloud, and we're going to talk about the 6 benefits of cloud computing. But before we do that, we're going to talk about like why was it significant that AWS released these services, and how did they do it differently, right? Because these are hallmarks of cloud. It's not just AWS. These are just hallmarks of public cloud computing in general. Now, one thing you're going to see throughout this course is that Amazon has put in language around like how do we model computing in a way that matches like our real world experiences in our lives. One of them is that when you walk into a coffee shop, one of the things that's interesting about AWS is that we go in and we say, hey, I would like to have a virtual machine because I need to host an application, or I need to run a container because I want to host an application, or I want to run an application inside serverless a la Lambda because I want to host an application. And so we make these requests of AWS, and they in turn like give back to us the resources or services that we've asked for. This is no different than us walking into a coffee shop and saying, hey, I'd like a double decaffeinated half calf with a twist of lemon, or a double caramel macchiato. Yeah, no, I kind of made those up. I feel like I've heard those before. But this is what happens, is that the customer goes and makes a request, usually of a cashier, not even a barista. The cashier interacts and we pay, obviously, and then we get our product. So there's obviously multiple steps to that. But if we talk directly to the coffee maker, we'd say, hey, can I get a cup of coffee? And they would say yes, and then they make it and give it to us, right? Now, that is the typical client server model, which all of us have been operating in for 30 years now, 40 years, where we say, hey, I want a web page, give it back to me, right? I want to retrieve a file, give it back to me. I want to see the contents of a directory, give it back to me. Those are typically what they call synchronous requests, which means we make a request and we get a response. If it was asynchronous, what would happen is it would be, hey, I've made a request, and the response would be, I'll get back to you, right? In other words, it's like I made a request, and when it comes back, it's not going to be actually in any kind of like time definition or any kind of conversation. It's like, hey, can I get a cup of coffee? Sure, I'll get back to you and let you know when that's going to happen, right? So with cloud computing, the thing that shifted is that Amazon made everything on demand, meaning you didn't have to talk to a person. You might think, well, who cares? Well, before, just so you know, before 2006, when we wanted to get servers, we had to go talk to somebody, get floor space, sign a contract, had to go through run legal. Everybody had to sign it, and we're done. Now, I'm not saying that the legal scanning still isn't appropriate, especially if you're taking on a new cloud provider. But Amazon changed this with a credit card and some verifiable identity information like a phone. They basically will give you access to like compute resources across the internet on demand. So, I mean, this is the on-demand delivery of IT resources across the internet whenever you want it, as long as you can meet some, a few standards. This, by the way, allows you to really only pay for either what you use or what you ask for. So there's a qualifier there where it says pay only for what you use. That's not true. That's not true in all cases. Let me qualify that a little bit. If you ask for a 4 processor, 16 gig virtual machine, and you only use 10% of it, you're paying for 100% of those 4 processors and those 16 gigabytes of memory. So it's really not just pay for what you only use, you're actually going to pay for what you ask for. So capacity wise, if you ask for capacity, or you're going to pay for it. There are a lot of services, by the way, that are really only pay when you run it. There's lots of them, Lambda being a great example, which is the serverless service. But they also have database services now that are completely on demand, meaning you pay for storage of your data, but if you run a transaction, that's the only time you pay for compute. So just know this on-demand access to services at a self-provisioned timeline across the internet, this is really what made AWS change the game. Because the only company that was doing that prior to this was really Heroku, and they were just offering hosting services. Amazon got into the game and said, we'll offer you infrastructure. Now, nowadays, I just want to say this, is that if you're running base infrastructure, you know, you're probably like leveraging kind of an old model of computing, which isn't necessarily a problem, because virtual machines are still an incredibly valid way to run applications. But more and more people are now going to higher level services because it offloads operational requirements. But you know, your customers probably have high security requirements as well. So the cost of that is control, which we'll talk about more and more as we get through all the services. But here's the bottom line. The on-demand delivery of IT resources across the internet. That's what this really is, with self-provisioning thrown in. Now, when AWS did this, by the way, in about 2009, 2010, Gartner, you know, the completely impartial like judger of the entire IT industry, which that's kind of a joke in case you didn't get that. Although they are pretty good. They basically said, look, here's what's going to happen in 10 years. Once AWS overcomes any security issues, because it's not that there were security issues early on, it's just that people didn't have faith that Amazon was somehow going to be better at doing security than them running it in their data center, which, you know, honestly turned out to be true, because now we've got public AWS, we've got GovCloud AWS, which is just for US government and related entities. And then, you know, I think at this point, the CIA and the NSA have both contracted Amazon to create private clouds for them that are not consumable by anybody but those agencies. It's kind of ridiculous, actually. So they must be pretty good at it. So notice that we've got 3 different ways, though, that we can kind of weave cloud into our infrastructures. The first one in the middle, on-premise, well, we've been doing that for, I mean, 20 or 30 years. That's how we got started, is that we were running, you know, servers in our data centers. And then cloud came along and said, hey, you know, let's just run everything in the cloud. And then, of course, we have hybrid, which is the blend, which 2010, Gartner said that, hey, any company has a data center now, you're going to be hybridized, which means you're going to be in your data center and you're going to be in AWS. That's what Gartner predicted. And what's happened is that pretty much any company that I know of that was created before 2012 and they had a data center, they're pretty much hybridized at this point in time. They're either partially in their data center and they're running some workloads in AWS, or they're running a lot of workloads in AWS and they're partially in their data centers. It just depends. So by the way, just to say this, another word for on-premise, just because this sometimes get bandied around, is private cloud. So sometimes cloud is referred to as public cloud because of the public cloud providers, and on-premise is sometimes referred to as private cloud. Now, here's a question for all of you. If you're running in a private data center, like one owned by Booz or one owned by one of your customers, what is the most popular virtualization software that you typically find in a data center, either public or private, like in the private industry? Does anyone know? What's the most popular virtualization software that enables private cloud inside these data centers? Well, Nathaniel, VPCs are inside AWS, right? What is the actual software that most of us, if we're running companies, are running inside our data center so we can run virtual machines? They've been dominating the industry for the last 20 years. Yeah, they're so good. VMware, right? So VMware actually has been dominating the industry for about 20 years. I think in 2000, 2001 is when they came out with their first product. And so when you talk about private cloud a la on-premise, like running inside of like a company-owned data center instead of one of the public cloud providers, you're typically talking about VMware. I do take a little bit of issue with people calling it private cloud, not because I'm such a cloud fanboy that I can't somehow coexist with VMware, but VMware offers just a fraction of the services that AWS offers or any of the cloud providers. So it's kind of funny that sometimes it's called private cloud. Now, the models for cloud-based deployment are just what I described. You run everything inside of AWS or other providers. You know, there's other people out there, but AWS, right, for this class. Do note, like I said, pretty much every company I know that started after 2012, give or take a couple of years, is pretty much all into cloud. They don't run anything in their own data centers. They didn't invest in data centers. They didn't feel the need to because they could just get somebody else to do it. Now, I know of one company who started after 2012 and their security requirements were so strong and stringent, they didn't run inside AWS. They had to run inside their own data centers, but that's because of the customers they had. On-premise, we talked about, right? This is where VMware shines, is running on-premise. You know, and they are evolving, so don't let me shortchange them, but typically they're in the data center. And then hybrid deployment is that blend where you run some workloads in private, some workloads in public. So some are on premise, some are on cloud. And so you don't typically span workloads across both systems. And one other deployment model that isn't listed here that people like buzz about a lot is multi-cloud. And I just got to tell you right now, multi-cloud is not a thing. So I know of no company that's running the same workload across multiple clouds. What I do know is that some people are optimizing where they're using some workloads on AWS, some on other cloud providers, because it just depends on the strengths and weaknesses of the cloud provider and who they have relationships with. So multi-cloud in a sense of like having multiple different workloads running on different cloud providers is the thing, but running the same workload across 2 or 3 cloud providers, I have yet to see that. That's kind of an illusion, actually. So, you know, just throwing that out there. Any questions thus far about the 3 cloud deployment models, whether you're deployed in cloud, on-premise, or hybrid? Really both. Okay. All right. So this is a picture of what exactly? Does anyone know what this is a picture of? Anyone seen this before? So this is actually an old picture of the AWS web console. The web console is one of the 3 ways that you can use to talk to AWS to get like services, right? And Sabrina, you're dead on. It is actually also a listing of some of their service offerings. Now, just so you know, there's like 300 and something services inside the offering. And by the way, this is the week of reInvent, which is the name of their convention. So there's going to be some publication of a lot of other services here as well. So just know. So this could get a little overwhelming. And just be aware that we're only going to cover maybe like 20, 25 services. And this is going to be at a super high level. So we're not going to deep dive into these things. But just know that like we're not going to talk about everything here. We're not even going to skim all 300 services. It'll be like maybe 20, 25, maybe 30, depending on, you know, honorable mentions, right? But there's a lot here. And the thing is that for most of the core certifications, including this one, which is foundational, you just need to know about 20 or 30. That's it, you know? And you don't even really need to know deep level detail. You just really need to know what they do and when it might be appropriate to use them. That's it. So don't let the console overwhelm you because it overwhelms everybody. I look at the console and I get overwhelmed. So don't let that happen, right? Let's just stay with the core services that we need. Okay. These next 6 things I'm going to talk about, these are actually on the exam. So I know it sounds strange, but probably want to take note of these because there's 6 ideas that Amazon has about the benefits of cloud computing. And it might seem a little bit like marketing speak. It's not actually. These are generally agreed upon like benefits, pros for using cloud, in this case, AWS. There are also some cons as well, but we'll stick with these. Okay. So first and foremost is that you can now trade, kind of like large capital upfront expenditures, like spending $1 million, $2 million, $3 million on a hardware. You can now trade that for a variable operating expense, meaning you can basically subscribe to a service, Amazon, in this case, AWS. And if you need more servers, great. You need less servers, great. But you can be very elastic or variable with your consumption. So it does allow you to invest in technology resources before using them, because you basically can test the waters and then give it back to AWS. You want to test MongoDB, you can start a document DB server and then give it back to AWS. In other words, you don't have to buy a license and test it at scale. You just start the service, test it at scale, and then give it back. So it's a little different in that it's variable operating expense. There's no more upfront capital expenditures that you have to worry about. So no more buying hardware. Second thing is that instead of running data centers, you can now focus on applications and customers. So now we've moved away from this fixed capital expenditure and hardware. We've moved away from having to spend money on data centers. And instead, we're going to pay for software services and we're going to operationally offload some things. And so not only are your hard costs going to be lower, but your soft costs can be as well, with the caveat of, do you have the skills and the automation, like the orchestration necessary to really make AWS cost effective for you? If you do not even follow basic best practices for AWS, these two things become really expensive, honestly. You can't use AWS as your the same way you use your traditional data center. There's just too many options to save money, right? So that's the second thing. First is variable costs. Second is the ability to optimize, right, costs, right? So that way you can move from a capital expenditure model and investing in data centers to a more flexible costing model, and you can focus on your apps and differentiators. Third, capacity. So I take issue with this statement. It says you can stop guessing capacity. What this means, by the way, is that now you can actually throw hardware at something. And if you've over provisioned the hardware for, let's say, a new application, then just give the servers back. If you've under provisioned, then guess what? Add more servers. So this kind of elasticity or flexibility allows you to scale in and out as needed. So this is the third benefit, is that your hardware boundaries are no longer like really your problem. They're not Amazon's problem. So this allows you, again, to have a lot of elasticity. And so you can now guess badly around your capacity needs and just fix it. It's just that simple. Number four, not three, because three was capacity. 4 is basically that Amazon, as you scale up in usage, the price per gigabyte per unit actually goes down. Now, I don't really like this because it basically says spend more money and you'll save more money on a per unit basis, but that is a reality of doing business. I think the thing that I like better around these economies of scale is that as more and more customers use AWS, not you, other people, Amazon gets better at, say, running storage, or gets better at running virtual machines. And then what's interesting is that they then pass that savings on to us. Now, let's be clear. This is a, $50 billion annual revenue business for them. So it's not like they're passing on billions of dollars. But just to say this, I think they've lowered prices on S3 7 times in the last 2 or 3 years. It might be a little less than that. But they keep cutting the cost per gigabyte for us to use storage, or they keep coming out with new virtual machines that have the same performance footprint of the old ones, but they're cheaper. So economies of scale really only benefits us, which, is interesting because it basically says if you spend more, I'll give you a lower price per unit. And as more people adopt AWS, we're going to pass that savings on to us, which, it's kind of like, oh, well, maybe we should invest more in AWS. No, you should just use AWS the way you need to. So that's number 4. So to review, variable operating expense, which gives you a lot more flexibility, Number two is that you get to optimize for cost, which means you don't have to spend on your data centers. You can now spend your money where it is the most benefit for your business. Three is that you no longer have to deal with capacity boundaries, with hardware boundaries. Amazon can deal with that. You just scale in and out as you need to. Number four is that as Amazon gets bigger, you get more cost benefit because they get more efficient at running these services. And then the last 5 and 6 is that you get a lot of speed and agility because, now because you don't have those hardware boundaries, when you now need things there, you want to test a concept, you want to do something new, you want to, stay ahead of demand because all of a sudden you got popular on Reddit and you're getting crushed. Well, guess what? Now your business has a tremendous amount of speed and agility to test ideas and respond to customer demand. So that's a great benefit of AWS, of public cloud in general. And then number 6. So, because we just talked about basically not spending in data centers and having variable operating expenses. We just talked about optimizing for costs that are relevant for your business. We just talked about basically economies of scale and being able to, scale in a way. As AWS scales, you get more cost benefit. And we just talked about capacity, so you no longer have to deal with capacity issues. And then, of course, being agile and innovative with your business, which is a big deal because now that can all be operationally offloaded. And the last is that if all of a sudden you find yourself in a position where you need to go global in minutes, that can happen. So whether you take a single website and make sure that there's low latency for that static data across the entire world, or you want to run multiple copies of your application across the entire world and you want to replicate data between them and make sure they're globally available, you can go global in minutes with AWS, which is a great benefit. All you need is a credit card and a phone and a unique email address. All right, so those are the 6 benefits. So to review, variable operating expense or your variable expense, optimizing where you get to focus on customers and applications instead of focusing on data centers. No longer having to have the inability to scale in and out as needed. You can just do that because Amazon's hardware boundaries are way beyond yours. Benefiting from economies of scale, both in the price per unit, but also in cost reductions that Amazon passes on to you. Getting speed and agility between capacity and demand and being able to focus just on what's important to your customers. And then being able to go global in minutes in case you need to get establish a global footprint. Questions about any of that? Anybody feel like anything was missing?
I know this is an AWS focused, but how does this compare to other cloud offers?
I mean, they all operate remarkably similarly. So, teaching Azure and Google Cloud, they all operate identically for the most part, because you see this convergence with competing products, right? Like, I think a good example would be like the iPhone and Android. Why the interfaces and some of the proprietary stuff is very distinctive. Them having an app store and having basic features like night lights and Bluetooth and all that stuff, that all merges. Same thing with the cloud providers, especially the big 3, which typically are listed as AWS, Azure, and GCP, Google Cloud. So they operate identically. The only caveat I will throw out there is that Azure and AWS are definitely focused on enterprise class customers and are trying to kind of be everything to everybody. Google's not really trying to do that. Google doesn't have the full scope of services that AWS and Azure has, but the things that Google does are typically better than the other two. Like, they do Kubernetes better, their big data stuff is better, but they don't have the full list of services, right? So that's probably the only distinction I would make as a broad stroke between the 3. But otherwise, they all have virtual machines. They all let you go global. They all have variable costs. They are trying to stay competitive with each other.
Awesome. Thank you.
Yeah. The only caveat is if you're looking for some fringe service, like you want high performance computing, Amazon and Azure will probably have it. Google may not have it. So, All right. So this slide is kind of an interesting slide because basically it just tells you that Amazon likes to bucket their services into categories. I have nothing else to add to that. So you can find them on the console homepage, which I actually will show you here in a bit. Okay, quick knowledge check. So type your letters inside of chat. If you were going to say, what is cloud computing? Which of these four options represented the definition we gave about what is cloud computing? Let's see. A, backing up files that are stored on desktop and mobile devices to prevent data loss. Sounds like an on backup utility. No. Deploying applications that are connected to an on-premise infrastructure. Not sure how that's relevant in the cloud since it's on-premise, but maybe. Running code without needing to manage or provision servers. No, that's definitely not it. That's serverless, actually, which just means hidden servers. So it's definitely going to be C. Even through process of elimination, it would be C, right? On-demand delivery of IT resources and applications across the internet. Only thing that's missing there is self-provisioning, but maybe on-demand meets that. Good. Excellent answers. You all get 1,000 points. These points aren't worth anything, but still, it's a fun game. It's like, whose line is it anyway? All right, what's another name for on-premise deployment? I mentioned it in relation to VMware. Maybe they have a thing for this letter. Yeah, definitely a private cloud, which again, I think I take a little bit of issue with, but it's okay. Get over it. Good. All right. How does the scale, how does the growth of cloud computing, of AWS in particular, help you save money? Right? As AWS grows, which of these would actually apply? It's a tricksy question, but I see that all of you answered it correctly, right? It's basically that, you know, as a large number of customers use AWS, they're going to pass back savings to you. That does feel a little markety, just to say this. It's like, hey, if you use this more, we might cut some costs. But it is true. They actually have followed through on that promise. Okay. All right, so then we cover the 3 cloud computing models and even threw in a 4th in there with multi-cloud, right? Talking about what that kind of could be. We talked about the 6 benefits of cloud computing, right? And then, you know, we just took a brief look at the general buckets of services, that there's compute services out there, there's machine learning, just mentioning that they like to bucket the services into categories. Any questions, soliloquies, interpretive I stances of anything that we just talked about? No one's ever taken me up on that last offer. I guess no one lives in a cold biome or has ice skates on, but that's okay. There's always next time. Hope springs eternal. That one day someone will do an interpretive I stance of AWS. I'm sure it's out there. Okay, so then let's talk about compute in the cloud. And then just know that I reserve the right in the middle of this to stop because it is a pretty dense module. We're going to talk about all this, and there's going to be an oral exam at the end of this where we're going to go through every single little bit. I'm just kidding. We're not. That's not going to happen. Here's basically what we're going to do. We're going to talk about the Elastic Compute Cloud, which is what EC2 stands for. Why is it EC squared? I don't know. But we're going to talk about virtual machines. That's basically what EC2 is EC2 is the virtual machine service. It is one of the 3 ways that in a general way you can host applications, which is by running a virtual machine that has an operating system inside of it. Anyone want to take a guess at the 3 operating systems that Amazon supports? What 3 general types of operating systems, flavors does Amazon support? Anyone take a guess? I'll give you a hint. Unix is not one of them. to give you a little preamble, Windows is one of the operating systems that the EC2 supports. Linux is the, oh, I see answers coming in now. Yeah, so Mac, Linux, and Windows. It's all right, that's perfect. Mac OS, yes. So just know those are the three that it supports. Anything out of that, outside of that is best effort. And don't get me wrong, people have put Solaris out there, iOS, I mean, all kinds of stuff. But Mac, Linux, and Windows are what AWS officially supports. Now we're going to talk about EC2 from a virtual machine perspective. Then we're going to talk about auto scaling and elastic load balancing, which are kind of add-ons. I know they're networking components, but they're add-ons for virtual machines, so you can get your virtual machines to be incredibly cost effective. And then we're going to talk about SNS and SQS, which are basically messaging services that are used in conjunction with your applications. And then we're going to talk just briefly about Lambda, which is serverless, which is just running applications. And then we're going to talk about the ECS and EKS service, which are container services, which is something you want to keep track of because containers are about to be the deployment de facto model, if they're not already the deployment de facto model for the next 10 years. So, which, you know, we'll touch on that. Okay, so we're back to the coffee shop. So here a customer's making a request, the barista fills the request. And so, you know, same thing with us, it could be a virtual server where we're like, hey, I need a Windows box. I need Windows 2019 on it because I need to host an IIS web server and it's got to, you know, host a bunch of videos and photos and whatnot. So this is where EC2 comes in. Now, EC2 is interesting because it basically allows you to ask for a virtual machine with a certain operating system of a certain size. I say, Michael, how do I know what the sizes are? I'm going to get to that. Just hold on for just a second. I'm going to get to that, right? But what this means is that you can go in and say, look, I want a Windows box or I want a Mac OS box, and that thing will boot in minutes, especially if you haven't asked it to do any configuration. I've seen a Windows box. I said that says no, it's a Linux box. I saw a Linux box the other day boot in 15 seconds on AWS. I got to tell you, when you're under pressure to relieve some customer demand, because all of a sudden your website got overwhelmed, booting a box in 15 to 30 seconds is actually really nice if you're still using virtual machines, right? Now, I take issue with that third bullet. It says pay only for what you use. In a sense, that's correct. You pay for the capacity that you use. So if you ask for an 8 processor 32 gigabyte machine, you pay for an 8 processor 32 gig machine even if you don't use it. So just be aware, it's really pay for what you ask for. So just keep that in mind. Here's how it works. You ask Amazon to launch a virtual machine. It asks you a bunch of questions. That machine launches, and then you can log in remotely into that operating system and manipulate it. So you can set it up, run a database on it, run Kafka, run calculations, you know, get it to crypto mine, you know, whatever you're into. I'm not here to judge, right? You know, I know some of you are into altcoin. You're avoiding Bitcoin because you think that, you know, Ripple is a better investment. I get it. My point being is that you launch a virtual machine, you connect to the virtual machine, you set it up the way you want to, and then you use it. Now, do you have to connect and set it up? No. You could literally launch a virtual machine that's already set up the way you want it by configuring what's called the AMI or the boot machine image. That's all it is. So don't feel like you have to configure this after you launch it. You could actually like pre-configure it before it's even launched. And when it comes up, it's ready to go and do what you ask it to do. But this is how this works. You just launch a virtual machine, go to town. Let's take a little digression to the console for a second. All right, so we're going to log in one of the 3 ways that you can log in to AWS. So here's the management console. Notice it's asking me to log back in. Now, notice it says at the top that I'm signing in as an IAM user. That's a user inside of an AWS account. So this isn't the owner of the account. I'm a sub user. Now, I've obviously got a password manager because, you know, I can remember about 30 passwords and then things start getting weird, right? So this is my demo account and it's got 2-factor authentication on it, which is a best practice. So, you know, 2 factors for the win, right? And here, if you had my phone and my passcode, oh, my password's going to expire in a day. I'm going to need to change that to that today. And here we are, by the way, in the console, and here's all the services. I know it's a lot. Containers over here, storage over here, but we were talking about virtual machines, right? So if I click on EC2, and notice in the upper right-hand side, it says that I'm in Ohio. Notice that this is not GovCloud. You all have indirect access to GovCloud through the portal that you run. I can't remember the name of the portal that you use at Booz, but I have to use the public infrastructure. So here I am in Ohio, and if I want to go launch an instance, the very first question it's going to ask me, it's going to say, what operating system do you want to use? And let's say I was like, you know what? I really love Ubuntu, so I'm going to use Ubuntu. The next question it's going to ask me is going to say, hey, do you want, what family of instance do you want? Now, if you just looked at that and went, Michael, what are you doing? What do all those letters mean with the T's and the A's and the C's and the D? Like, that's crazy. Just so you know, this is all the different like versions and families of EC2 virtual machines that you can run. They are all designed for very explicit purposes, which we're going to talk about because there's only 5 general buckets. I know this is a little throws you off a little bit, right? Because it's like, oh my God, there's so many letters here, Michael. What is that all about? And there's only 5 general types, just so you know. I don't know why they like labeled them so oddly, but Amazon doesn't always make things intuitive. Not always. So let's say I'm running a test server, which I generally associate with T. Now, Amazon would probably club me if I said that, because the T's are considered to be general purpose, but I use them as test boxes because they really are better for test boxes from my perspective. So let's say I'm going to use the T3 family of box, right? And then notice these t-shirt sizes. I got nano, I got micro, I got small, I got medium, I got large. And notice that typically around the small to medium, the memory and processors start to double. Now, the T series is not a great example of this because they don't really follow this pattern, but every other family does. So for example, if I switched over to say like a, let's do an M5. So see the M5 family over here? Notice how it goes from 2 to 8, and then it doubles, and then it doubles, and then it just keeps on doubling, right? So just know that every other machine will double memory and CPU if you go up a t-shirt size. The T series is a little bit of an exception to that. So if Mary comes to me and says, look, I got a project and I need you to launch a 32 processor, 128 gig machine, which of these types of machines am I going to launch? Someone type it in chat for me. 32 processors, 128 gigs of RAM. What's the type of machine I'm going to launch? Well, definitely an M5, right? But which specific M5? Yeah, good. So the M5 8X large is 32 processors and 128 gigs of memory on the system. That's not storage, because just so you know, storage is separate. Disk storage is separate from the virtual machine for most of these boxes. Okay, last question, and then we'll get away from all these crazy numbers. If I needed a 25 gigabit network connection, I needed that level of network performance, and I didn't want to run a metal box. Which of the M5s am I going to run to get 25 gigabits of network performance? Didn't make it easy this time. Didn't hover my mouse over it. Yeah, there you go. Good. So it really is just that simple. You can just use the box that has the characteristics that you're looking for. Now, a metal box, by the way, is like a bare metal server. So probably not going to do that, but still a valid choice. Like I saw the Sabrina list there, totally valid choice, Sabrina. Still could use it if I was okay with metal, right? Metal, by the way, just gives me a bare metal system, which I know that sounds weird, but you can actually get bare metal boxes inside of AWS. Okay, So 24 extra large if I needed 25 gigabits of backplane performance. Now, but Michael, what if I need to crypto mine and I'm not doing Bitcoin? Because just so you know, Bitcoin doesn't use GPUs to mine. They use these things called ASICs, but every other alternative cryptocurrency like Ripple and Ethereum and all that, they use GPUs, which is why we're having a GPU shortage. You're like, Michael, I need a box that has GPUs in it. Well, guess what? If we switch over to this P series, like let's say the P3 box, notice that this has virtual CPUs, but it doesn't list the fact that it also has GPUs attached to it. So you're like, okay, well, Michael, how do you know that? Here's the catch. If I go into, if I go to Google and just type in EC2 instance types, this is where Amazon's documentation fills in the gaps for us. So here are the Amazon EC2 instance types. And notice that on the left-hand side, it says general purpose, compute optimized, memory optimized, accelerated computing, and storage optimized. I warned you, there were only 5 categories of boxes here, even though Amazon went crazy and made all these letters. I don't know why. I'm not in charge of marketing or labeling or product naming. So I'm not in charge of anything in AWS. So general purpose boxes are these T series that we saw and the M series, like the M5 that we were just looking at. What you need to know is that Amazon has boxes that are designed for general purpose workloads, for compute optimized workloads. This is the C series, by the way, C for compute. For memory optimized workloads, which is generally R for RAM. So you can ignore these other drive letters. They're weird, or these precursors, they're weird. Then they have storage optimized, which only comes in D's and I's, even though there's an H there. D for data warehousing, I for intense IO. And then they have this accelerated computing option. And guess what that is? That's all GPU attached systems, which means they not only have a central processing unit, they have a graphics processing unit in them as well, like a video card, right? Now, what do you, by the way, anyone, I know at least one person on this call probably knows what you would use a GPU attached system for. Could that person answer my question? I'm gonna put you on the spot, but I can call your name out. What kind of role and or products do we generally use for operating systems that have access to a bunch of graphics processing units? Because you're like, Michael, if I have a central processing unit, why do I care if there's a bunch of video cards on here? Can someone answer that question? Oh, wait, first of all, Brandon, you just warmed my heart by saying that. Gaming, yes, absolutely. Because I mean, who wouldn't want a 24 GPU system on their gaming rig? But gaming across the internet is pretty horrible, actually. So unfortunately, that's not the use case for this, actually. What's other than crypto mining, what's a great use case to have GPUs inside of your hardware? Like, what's the business application? Because you're probably like, hey, I can understand why I'd want to be heavy on processor. I can understand why I want to be heavy on memory because maybe I'm running a database. I can understand why I'd want to be heavy on storage because maybe I'm running a data warehouse or something like that. But why would we want GPUs inside of our operating systems? That doesn't make any sense because most of us think of those as being used for gaming. 3D printing wouldn't be bad. Actually, what it's actually used for is, oddly enough, GPUs are really great at certain types of calculations, which is why crypto miners use them. And it's also why data scientists use them. Just so you know, data science and machine learning can really kill a set of GPU processors. Like they can really make use of those. So a lot of really great number crunching actually happens faster on a GPU, on like basically a video card, than it does on a central processing unit. So just something to file away for future reference. Okay. Now we're gonna diverge for a second. We're gonna come back to the family types because you're like, Michael, you just took us on this crazy journey with 5 categories, and then now you're gonna take it away from us. Don't worry, we're coming back. My point to showing you all that was that when we run a coffee shop, we generally don't have everybody doing everything. We have one person who's really good at making the coffee, another person who's really good at processing transactions, and then maybe someone's doing stocking in the back end. This is relevant because those 5 family types of EC2 virtual machines that I just showed you, this is the general purpose, the compute optimized, the memory optimized, and then there's accelerated computing and storage optimized. These categories literally match what I just showed you on this webpage, which, by the way, I'm gonna paste in the chat so you can have it. Now, here's a problem. Do your customers come to you and say very clearly that they want a, T3A as their virtual machine? Or how do customers come to you? How do customers communicate to you that they want their application to run in a certain environment? What do they say about the characteristics of a virtual machine? Can anyone take a guess? What do they tell you typically? Do they say, you know what, Michael, I really want an M5 extra large off of Amazon? Is that what they say? Exactly. So Nathaniel, let's say a specific use case for their clients. So that's perfect. So let's say, Nathaniel, they come back and they say, I want to run a database. What's the next thing they usually tell you when they say, I want to run a database and I've got a database of a certain size? Do they tell you how many processors? Do they tell you how much memory they need? Right? That's typically what happens, is that the customer will come back to us if we're lucky and they'll say, hey, the vendor documentation says I need a database that has 32 gigs of RAM and 8 processors in it. And you might say, really? Are you sure you need that? And you just have to take it at face value, right? Because we're consultants and so we don't really know, but they tell us. And so we might try and do some sizing, but for the most part, we're like, okay, we'll take it at face value. How would you find, out of all of Amazon's offerings, how would you find a virtual machine that had 8 processors and 32 gigs of RAM? What are you going to do? Go through every single page here and try to figure it out? Could you go over to the launch wizard and say, maybe I could filter it by just doing all of the instance families. Maybe I could just go and scroll through here, right? Well, here's what happened. So there's this great website. You should definitely, no, it's not EC2 Spot Workshops, although that's a fun website too. There's this website called instances.vantage.sh. You should bookmark this, or at least just remember that it's instances.vantage.sh. And let's say someone comes to you and says, Michael, I'm going to run Elasticsearch because I love databases. I need 64 gigs of RAM. And it's compute heavy, so I want half of that in processors. Guess what just happened? We just found a box with 32 CPUs and 64 gigs of RAM. And so now we got to go look up what a C5A is and a C5GN is. I know off the top of my head, but we have to go look it up. This is an AMD processor, by the way. So let's say the 65A is the one we want to use because honestly, these Gs are ARMs. Although I don't know what an I is. Oh, that's right. They started doing Intel processors with I's. So it's probably an I. So my point being is that now I can come to this website and find all the Amazon boxes based on specifications instead of trying to go through all the families and figure out who's doing what with what, right? And maybe you don't have the processors. Maybe no one cares. And you just are like, you know what? I need a box with at least, let's say 24 terabytes of memory. I just want you to know, by the way, that 24 terabytes of memory is ridiculous. And you know why? This is actually a bare metal box. So I just wanted you to see, though, that you could actually get a 24 terabyte system with 448 CPUs if you wanted to. Notice that the pricing is not listed on the right-hand side. So just know you can get really, really tiny, cheap boxes on Amazon. You can get really, really big, expensive boxes on Amazon. My main point in showing you this is that this website will allow you to find a box from Amazon's official offerings by either virtual CPU, by memory, by storage, right? So just know you can use this website to find the size of virtual machine that you're looking for, okay? This all relates to this. There's only 5 categories: general purpose, compute optimized, memory optimized, GPU attached, and storage optimized. Okay, Questions about any of that? No? Okay. All right, so let's do a little link test here. If I wanted to run a database and I needed most everything to stick in RAM, which of these am I going to choose? No? No guesses? Am I going to use general purpose, compute optimized, memory optimized, or storage optimized? Generally, like I'm going to have things stick in RAM, right? I'm going to use C. But D is not a bad answer because many times databases will use storage optimized instances. But usually if it's memory heavy, it's going to end up being like a memory optimized box. By the way, bonus points. What letter did I say that the memory optimized box in general start with? It's not M for memory, right? It's something else. Good, Tyler. R's. That's exactly right. So R6s, R5s, R for RAM. So for memory optimized boxes. Okay, good. All right, next one. What is suitable for data warehousing applications or for IO intense operations? Which of these boxes is optimized for data warehousing or for storage optimizations? Oh, come on. I kind of softballed that one up at the very end, right? I did, right? Storage optimized for storage optimizations, right? So D is it. Okay. Now these next two, these are super easy. Balances compute, memory, and networking resources. So as far as performance, it's more average. Which of these boxes is more about balancing compute, memory, and networking resources? Good, that's right. A, general purpose. And of course, that leaves B for compute optimized, right? Which means it offers it's more focused on processing. Good. All right, hope you took notes. This shows up on the Cloud Practitioner exam. You need a database intensive box that has high memory requirements. It's going to be a memory optimized box. You got a bunch of number crunching to do because you're doing batch processing, right? Which is very compute intensive, or you're doing some kind of like analytical report. That's going to require a lot of compute power. So that's going to be compute optimized, right? So just, in general, know what the buckets are. By the way, which is the one missing from here that does GPUs? Which one of these does GPUs and is totally missing from this setup? Perfect. Accelerated. That's right. Usually the P series, the G series, there's a couple other letters, but the P's and G's are typically it. Okay. I feel like we've been going for about an hour. It might be a good time to take a break. So we're going to get into pricing and a bunch of other stuff that's going to require more note taking, right? So it's 9:35 right now. Let's come back in 10 minutes. So let's take a 10-minute break and come back at a quarter till. Okay, I'll put a little timer up and we'll go from there. Okay, we'll see you in just a minute. All right. Don't have any questions thus far about any of these family types, virtual machines in general, as we move through more virtual machine context, cloud computing models? No. Okay. Alrighty then. So let's talk about pricing, or also known as confusing ways in which pricing could work inside of AWS. Let's see if we can provide some clarity for that. All right. So there are, let's see, I think as of today, there's like 6 ways to do pricing in AWS for Elastic Compute Cloud. Now, one of these I know for a fact actually crosses over into other services, meaning you can use this model for other services as well. But the second most expensive way to use AWS is to be like, we are not in a contract. We have no relationship, but I still want to use your virtual machines, but I'm just going to pay for them as I use them, and I'm going to give them back as I don't need them. This is called on demand, right? So there's no contracts. It's great for workloads that are, say, like 6 months or less. But things that you're just going to run occasionally, if you want to run a test, proof of concept. Oddly enough, though, most companies still use on demand because they're afraid to get into a contract with AWS. I gotta tell you, if you're in a contract with Microsoft or Google, like, just get into a contract with AWS. They're really great partners actually to deal with. So this is the this is the retail price for. So for example, if you launch a virtual machine and it costs $1 an hour, that's the on-demand price. And when you go to that website that we were looking at before, let's pull this up here. The one, this EC2 instances.info, the one that I posted earlier, the price is over here. So let's go pick one that has a price attached to it, because they're not going to tell you the cost of the bare metal boxes. But let's say we do a T3. So notice over here, like the Linux on-demand cost is 0.04 cents an hour, basically rounded up, 0.05 really. That's for a T3 medium. So for a 4 GB memory, 2 CPU system, that's going to cost you 4 cents an hour. So multiply that times 720 hours or 732 hours or whatever per month. And that's what that box is going to cost you on a monthly basis. That on-demand cost is full retail price, no special provisions. And that means that you're going to be sharing that hardware with other people. But it doesn't matter. The security cordons are so tight, you can't actually see anybody else's data. You can't see the other networking. You can't even sniff their packets. No one's going to be able to see any inside your account other than you. So this is on demand. Now, one of the cheapest ways to use Amazon is, because on demand means you want access to that system 24/7. But let's say that you have a report and you want to run that report over a 30-day span because it just needs to be completed by the 1st of next month. And you have an application that what it does is it processes some data and then writes it out to another database. Processes some data, writes it out to another database. That application can actually be interrupted. Like you could crash that application, and what it would do is it would pick up the batch that it was on, run that batch, and then write that data out. In other words, the system has checkpoints, right? Regular checkpoints. Well, if you're like, I don't really need a 24/7 box. I just need a box that can run at certain intervals of time. You can actually run what's called spot instances, which are 90% cheaper than on-demand instances. But here's the catch. With Spot, notice how it says ideal for workloads that have really flexible start and stop times, meaning you have to get it done over a large period of time. Spot instances, what happens is that when Amazon has extra capacity, let's say, for example, in a data center, they could run 1,000 M5 larges. 1,000 M5 larges. But right now, people are only, like, their customers are only using 800 of those M5X larges. So what Amazon does is AWS goes, oh God, I've got 200 extra M5 larges in this data center. So instead of you paying $1 for them, which I just made that up, by the way, it's probably more than that. But let's say you pay $1 for them, Amazon will come back and say, look, who's willing to pay 70 cents for these boxes? Who's willing to pay 20 cents for these boxes? Who's willing to pay 30 cents for these boxes? So if you put a bid in and say, look, I'm going to put in a spot bid and say, look, Amazon, if you have M5 extra larges that come up and they're 30 cents, I'll pay you 30 cents an hour for those boxes. Give them to me, and then let me run my application. Now, here's the catch. Let's say you tell Amazon, hey, Amazon, I don't want to pay $1 for your instances. I'll pay 30 cents for these instances. And you put in a spot bid of 30 cents and you win the bid. Amazon's extra capacity gets so high that Amazon's like, hey, we'll give you to them 30 cents off the dollar because we'd rather make some money off of these instances than just have it just sitting there doing nothing. And then all of a sudden, 500 customers come along and ask for an M5 extra large. You will get a 2-minute warning and your box will be shut down and it will be given to the other customer. Now you won't see who it's given to or any of that stuff. You'll just get a 2-minute warning, right? That's the cost of getting that 90% savings or 70% savings or whatever, is that your application has to be able to have flexible start and stop times. Now, you might say, Michael, that sounds horrible. Why would we ever do that? Well, what if it takes $10,000 for you to run this report over a 30-day period, and using spot instances, you could get it done for $3,000. Multiply that times 1,000 reports. Next thing you know, guess what? Spot instances start looking pretty appealing, but only if your application is designed to take advantage of it. So otherwise, guess what? You're going to be with the rest of the world. You're going to use on demand, because that's you get 24/7 consistent access to the box. As long as you have that box up, that box will never be taken away from you. But with spot instances, that box could be taken away from you. That's the cost of a up to a 90% discount. Spot, by the way, is great for GIS data, like oil and gas, geonomic data, like batch processing along those lines, reporting, survey data, any data processing job, spot instances are great for. Okay. So remember, on demand is the second most expensive way to use AWS. Instances might cost $1. If you go with spot, instances could cost as low as 10 cents for the same instance that you paid $1 for on the on-demand side. But remember, spot is reserved for applications that can be interrupted. If you get an exam question and it says, hey, we're looking for the type that can withstand, and we have an application that can withstand interruptions, you automatically know that they want you to use spot instances for that. Okay, so on demand is a flavor. Spot is a flavor of licensing. We've got 4 more flavors, right? We've got reserved and compute savings plans. Okay. So reserved, also on the left-hand side, also known as reservations. This can, I give you up, I think it's up to like a 70% discount, or maybe it's 66% now, 66%. You want this when you're thinking about using on demand, but you're like, this project's going to last for a year, or this project's going to last for 3 years. Guess what? You're going to use reservations for this. You're going to use reserved. What this means is that, let's say it's an M5 extra large and it costs you $1 an hour on the on-demand side of things. You're going to go back to Amazon and say, look, Amazon, I'm going to use an M5 extra large in Ohio in the first data center. So US East 2A. I'm going to do it for a year, and in exchange, you're going to give me a discount. And let's say Amazon comes back and says, oh, that sounds great. I'm going to do a year. Awesome. I will give you a 30% discount off of that particular region in that location. So instead of paying $1 24/7, you're going to pay 70 cents. That's a 30% discount off the full costs. All of a sudden, it's like, hey, I just saved, just by committing to running that workload for a year and paying for it for a year. So just so we're clear, you are going to commit to paying for that workload for a year, whether you use it or not. You basically are going to get a 30% discount or more. Those numbers are all speculative, by the way. Just depends on where you're at. That's what a reservation is. A reservation says, I reserve this capacity for a year or 3 years. Amazon, will you give me a discount if I give you my commitment to pay for it? That's what a reservation is. Now, the other option, which is actually relatively new, it's only a couple years old, is a compute savings plan. Now, here's the funky thing about a compute savings plan. With a reservation, you're like, hey, man, I'm going to run this web server for a year. Give me a discount. With a compute savings plan, instead of it being based on servers, what you do is you basically say, look, Amazon, I'm going to give you $10,000 and you're going to give me $14,000 worth of compute. And Amazon's going to go, oh yeah, you want to give us money? You want to give us a bucket of money now? Absolutely. You give us 10 grand, we'll give you $14,000 worth of compute. Right? And so what that means is that you just saved money because instead of paying a price per dollar, right, you're now paying a price per 70 cents. So same thing as what you got with reservations. The difference is that with a compute savings plan, you can get it just for EC2 virtual machines, or you can get it for all of the compute platforms inside of AWS. Also, compute savings plans are a lot more flexible because they don't care what size of instance you run, right? They don't care what size of instance you run. You run any size instance you want. It's going to come out of that bucket, right? So it's still on demand, but it's going to come out of that reservation bucket. So you're still going to get a discount, but you get a lot more flexibility about the t-shirt sizes of your virtual machines. So reservations are very fixed, meaning you don't have a whole lot of flexibility. Once you commit to an M5X large, it's going to be hard for you to change that. With the compute savings plans, you can say, look, I want a discount, but I don't want to lock myself into a t-shirt sized virtual machine. I want to run whatever virtual machines I want. I just want you to give me a discount. So just so you're aware, in case you were curious, Amazon will take a large bucket of your money and give you a discount. So that's what a compute savings plan is. Questions? Does that make sense? Okay. So remember, on demand, you're not in a relationship. You're not in a commitment with Amazon, right? On demand is you just paying full retail price. Spot is only for applications that can withstand interruption, but you can get up to a 90% discount. Reservations are when you were running on demand, but you're like, I'm going to run this for a year or 3 years. So don't run on demand. Amazon, give me a discount. By the way, it doesn't cap at 66%. That was actually me misremembering compute savings plans. I think you can get up to like a 75% discount with reservations. It just depends on how long you commit for. So these are two ways in which you can kind of get into a committed space with AWS, and then they'll give you a discount in exchange. Remember that both of these plans require a 1 or a 3-year commitment. So if your workload's going to run for a year or 3 years, you want to consider this. Don't do on demand, right? All right, last one, which is really actually 2 in 1. All right, so this is the last type of way you can purchase virtual machines off of Amazon. Dedicated instances and dedicated hosts. This is the most expensive way for you to use AWS. It's the most expensive way. And here's why. I know this is going to sound strange, but with a dedicated instance, they actually put you on a tiny little box that matches your hardware specifications exactly. And with a dedicated host, you buy a big box and you run multiple virtual machines on there. And nobody else, no other customer is on that hardware that you're running your virtual machine on. That's crazy. Like, to think about this, when you run on demand and when you run regular virtual machines, they're on hardware and there's a bunch of other customers on there. Now, let me be clear. There are huge security barriers between you and the next customer. But let's say you're working for a very tight division of the Department of Defense, and they're like, no, you can run in GovCloud, but you can only run it on our own dedicated hardware that is only for us in AWS. So this is when the requirement is that we have very stringent either licensing or security requirements, and we can't have this box either moving around to other physical hardware, or we need it to stay on the same piece of physical hardware, and nobody else, no other customer of AWS can be on this hardware, right? So these are like for compliance, can't be on the same thing, right? It just basically, these are isolation licensing types. This is the most expensive way to run AWS, right? Dedicated hosts in particular are the most expensive, maybe not dedicated instances. Okay, so recap. On demand, second most expensive, very flexible. Spot requires a huge amount of flexibility, 90% discount if you can withstand interruptions. Reserved, just like on demand, except you are committing to a certain box in a certain location for 1 to 3 years, and they'll give you a pretty steep discount depending on your level of commitment. Compute savings plans isn't based on you committing to a size of virtual machine. It is based on you saying, look, I'm going to give you a bunch of money, Amazon. Give me a discount. And then last but not least, you've got stringent licensing, location, or security requirements, and you need either to pay for an entire host that's just yours or an entire dedicated virtual machine that's just yours. So those are the kind of the 6 options. All right, here we go. We're going to test your knowledge. What's the difference between a compute savings plan and spot instances? You're like, what, Michael? Let me ask you this. Which of these two require you to have an application that can withstand interruptions? A savings plan or spot? Okay, good. This is easy. Which one would you use if you had 30, 60, or 90 days to run a report? In other words, you didn't need it tomorrow. You didn't need it next week. You just needed to get it done within the next 30, 60, or 90 days. And the application writes out to an external database, right? That'd be spot. Which one of these are you going to give Amazon a bunch of money and they're going to give you a deep discount on the use of that money? Go ahead. Which of these is best for something that is a consistent workload that needs to run 24/7? Good. I'm just going to forewarn you right now. Spot instances are awesome, but if you do not have your automation game together, meaning you don't know how to configure a box on the fly or make machine images that configure the box on the fly, you're going to have a bad time with spot instances. So don't use spot instances unless your automation game is strong. Your automation kung fu needs to be good, okay? With compute, you can figure that out. I think that said exactly what I said. Okay. Okay. Now we're going to move past virtual machines and we're going to move into spaces where let's find out. That's weird. Let's move into some like auxiliary tools. How do we augment our use of virtual machines? Because you got to remember, virtual machines are now 20 years old, which, just so we say this, that doesn't necessarily mean they're bad. It just means that if we don't evolve them, because the entire industry is evolving them, and we use them the way we've been using them for the last 10 years, we're really not optimizing our business, honestly. We're just not. The day of like having static virtual machines just sitting there constantly existing and running resources, those days are evolving. It's evolving away from that. So let's talk about how you shrink and expand and create flexibility and elasticity inside your virtual machines. This is where autoscaling comes in. This is one of the 3 pillars of the secret sauce that really makes any virtual machine in any public cloud provider better than most people's data centers, honestly. Like, this is the thing that makes it better. Why? Because this is where your virtual machines get cheaper and yet at the same time stay with customer demands. This is where it's really cool. Okay, so consider this. We got our people coming in asking for coffee. They need their, double macchiatos, right? Or whatever. Or maybe they're drinking tea. Maybe it's, I don't know what the name of someone is who makes tea, but what if it's not a barista? Maybe they're just making tea, which is the second most drunk beverage in the world, by the way, after water. So coffee is an American addiction mainly. So you got low demand where you've got 2 customers talking to a barista, but then all of a sudden there's 4 customers. What do you do then? That one person can't handle it. So what you do is you add a second barista, right? Or barista. So, typically what happens is someone's working the cashier and then you've got people in the back end who are making the coffee and making the product, right? So in order to make sure that first barista doesn't get overwhelmed, you have to add a second one. That's pretty standard we are used to this, especially when it comes to website consumption. So in the purple or blue, that's demand. This is where customers are coming in and hitting our website. In a normal fixed hardware situation, what we've done here is we're saying basically that I'm going to just buy hardware at that top level, and I'm not going to adjust my hardware based on demand. Why? Because we don't do that in data centers. You know what we do in data centers? Sorry, that was really bright. In data centers, we buy fixed hardware capacity, and that's the hardware capacity we have. In AWS, we don't do that. With cloud providers, we don't do that. Instead, we shift it so that hardware capacity is just ahead of demand. So it looks more like this, right? Where I've got 2 active virtual machines because that's my desired. And as customer demand goes up, I'm going to add more virtual machines. And by the way, if those customers go away, I'm going to scale those virtual machines in. So I might start with 10, scale up to 50, scale back to 20, scale up to 30, scale back down to 10. Auto scaling is what allows that elasticity to happen. Auto scaling does require a little bit of automation. But other than that, auto scaling is pretty easy to set up nowadays. It's kind of an afterthought. And when you run virtual machines, even if you just had an auto scaling group of 1, let's say you got a developer box, let's say it's running Jenkins on it. You want to make sure that thing, if it fails, it comes right back up, right? Because let's say Amazon has an outage or whatever, which doesn't happen very often, but let's speculate. So let's say your Jenkins box goes down and you've got your home directory externalized. So what happens is that that box crashes. You've got an auto scaling group of 1. When that box crashes, the auto scaling mechanism will bring the box back up and restore the data based on whatever automation you've set up. So whether it's 50 web servers or 1 important developer box, you can actually make an auto scaling group to allow your systems to scale up and down as necessary. Now, just a word of caution here. You can also do this with some databases, but be very, very careful. If you have a data store, or data application of any type, it's not going to work very well in an auto scaling group. This is mainly for applications, okay? This is not for Elasticsearch or for other kind of those mechanisms. You can do it with some of the NoSQL databases, but you can't do it with an RDBMS easily. So just know that if you've got data in your systems, this is really just for application servers and web servers. It's not really for data stores of any type, okay? There's other solutions for data storage, okay? Remember, if you're going to scale out or scale in, if you're going to add boxes and remove boxes, auto scaling is your friend. Okay. Now, I would be completely remiss if I talked about auto scaling and I didn't talk about hiding your servers, or also known as load balancing. So what this means is that, let's say we've got our 4 customers, and I've got 1 talking to 1 barista, and I've got 3 talking to the other barista. So the other guy, other person's overloaded. So then how do we redistribute load? How do I point them in a balanced way across whatever number of baristas I have? Well, this is where load balancing comes in. Load balancing, just to annotate and highlight this just a little bit. Let's say I got a low demand period, and instead of going straight to the box down here, they go straight over to the load balancer. The load balancer is a virtual network endpoint. It's not a device. So you're going to think of it as a single point of failure. It's not a single point of failure. When you go to www.amazon.com, you do not actually go to servers. You actually go to an Elastic load balancing device. That device then distributes your request to one of the backend servers. So as demand goes up, like it does over here, right? This person in green is going to hit the load balancer, and the load balancer is going to send them to a server. This next person is going to come in and make a request that they're going to hit the load balancer. They're going to go to another server. And as you can imagine, this continues. If one of these servers go down, let's say that this server goes down, what will happen is that, let's say that green guy was going over here. Now, instead, because this server is down, green guy is going to be directed over here. This is what a load balancer does, is it hides the number of servers that you have in the background So whether you have 1 or 5,000, the load balancer's job is to distribute traffic equally across all those systems. So load distribution and network distribution and network balancing, this is what an elastic load balancer does. So while auto scaling's job is to basically expand and contract the number of servers that are behind the load balancer's job is to distribute traffic to those systems, and it's to hide away basically what's going on the back end, okay? Those two pieces, auto scaling and elastic load balancing, work so well with virtual machines so that you can make them elastic and more cost effective. Questions of any type? So the EC2 instance is actually the barista in this case, right? So Ian, since the barista is the one who's generating the work and the product, in this case, the EC2 instances are the barista, right? They're the ones who are generating the coffee. The exchange between the barista and the customer, that would be governed by the load balancer. Okay. Okay. So here's the answer. And here's your shorthands. Is it AS for auto scaling or is it LB for load balancing? So number one, removing unneeded Amazon instances when the demand is low. Is that adding and removing instances? Is that the auto scaling group or is that the load balancer? It's definitely the auto scaling group. Now, don't get me wrong. The auto scaling group, by the way, is going to talk to the load balancer and say, hey, by the way, I'm removing a box, so take it out of rotation. But the auto scaling group is the one that makes that decision. When you define the auto scaling group, you said, look, if we get down to 50 active connections, I need you to drop to 5 servers. The auto scaling group is what does that. Okay. Adding a second Amazon EC2 instance during an online store's popular sale. Is that auto scaling or is that the load balancer? Good. Anything involving actually changing the number of booted virtual machines that either adds virtual machines or reduces them, that's definitely going to be EC2. It's going to be the auto scaling group. Sorry. Good. So auto scaling. Okay. Number 3, distributing a workload across several EC2 instances. Is that auto scaling or is that load balancing? Good. Yeah, that's load balancing. Perfect. Number 4, ensuring that no single EC2 instance has to carry the full workload on its own. Whose job is it to make sure that load is distributed across an entire set of EC2 instances? That's exactly right. Load balancing. Perfect. Automatically adjusting the number of EC2 instances based on demand. Well, that seems remarkably similar to question number 1, right? So see, you're answering auto scaling. That's perfect. Good. Providing a single point of contact for traffic into an auto scaling group. Who is that? Good. I mentioned that earlier. Perfect. Excellent. Okay. So we talked about EC2 and its 5 different types, family types of systems. We talked about the 6 licensing types inside of EC2. And then we talked about 2 adjuncts to EC2, which are basically auto scaling and elastic load balancing. Does anyone have any questions before we talk about some messaging services that can help with the applications that are running on EC2? Okay. Let's talk about some messaging services. Okay. Let's say that you have a Java application and your architect has come to you and said, you know what? This thing was written in 1998. It's still working great, but it's kind of long in the tooth. It needs a refresh or refactor. Can we start slicing some of these business concerns out into their own independent applications so that separate teams can work on these independently? Because I've got 5 or 6 teams working on this single application. It's got a bunch of subcomponents, and we're having trouble kind of doing integration tests and testing. And there's a lot of tech debt here, and it's really painful. That, by the way, is a good reason to start looking at this. Microservices. When you go to make a change to an application and you have teams that are blocked by each other because they can't do testing, or they're waiting for another team to finish their component before they can deploy the entire application, and you're running into all kinds of like integration failures and communication failures and that kind of thing. When things get too tightly coupled, where you can't make changes and you can't deploy, that's when you probably want to look at a microservices architecture. This is a design pattern. There are ways, by the way, to migrate your monolith over to a microservice. Now, why do they put this here? I think they just want you to be thinking about how to loosely tie together your services. And so this is why we're going to talk about 2 services that can allow you to kind of act as an intermediary between components. So, and there's 2 options for this. One is called SQS and one's called SNS, but there's also other AWS services. Any questions about monolith to microservices just at that very, very high level before we go forward? Okay. So SNS is a service that could help you with inter-component communication, right? How does it do that? Well, SNS is a simple notification service. And let's say you have a bunch of customers who want, to know about coupons, coffee trivia, and new products. We're all familiar with this because we all have email subscriptions. So we know how this works. We've seen this before. This is not a surprise to us, right? So, matter of fact, if anything, we all have too many email subscriptions. And so what happens is that you as the business can push specific updates to specific topics to support whatever interests your customers have. Obviously, if you start sending the coffee trivia people coupons and they didn't sign up for that, they might be pretty irritated. So it allows you to personalize the interest based on what they're actually interested in. This is what SNS does, by the way. SNS allows you to publish to certain topics, and whether it's an email, a text, a web post, a mobile push, a push to another AWS service, this allows you to push information to users who have requested it. This is a subscription model, which means that these users are receiving information from topics that they have consented to subscribe to, right? So this is a subscription service. People subscribe, and then they receive the content that you push along the subscription. Now, this is a little different because this can help you with intra-component communication, because you could have one component pushing to SNS, which then pushes to 3 other components. So most people wouldn't necessarily use it that way, because mainly we use APIs for that kind of intercomponent communication. But if you need to have one service in AWS trigger 3 other services, SNS could be the way in which you get that done. Okay. Now, this is a push service. So it's also called publisher subscriber, so pub sub as well. Now, the other service that is not a push service, but is a pull or pull service, is the simple queuing service. This service allows you to take like messages from one component, stick them on a messaging bus, and then have other components come talk to the messaging bus and grab and process. Now, in our coffee example, we do this because the customer orders from the cashier processes the order and places the order on a queue. And then the barista goes to the queue, retrieves the next coffee order, processes it, and says, "Hey, your half caffeinated, decaffeinated half caff is up. We got it." Or your caramel macchiato is up, or your pumpkin spice latte is up. And so what happens is that the cashier doesn't necessarily talk directly to the barista. It just says, "Hey, order number 2 is in, order number 3 is in, order number 4 is in," and the baristas just work the orders as they see them in the queue. This is what the simple queuing service does. The simple queuing service allows you to put messages on a bus, and then your consumers pick up those messages and process them. So SNS is the simple notification service used to notify and push messages to subscribers. SQS is the simple queuing service. You put messages on the queue, and then people grab those messages off the queue. Questions about either SNS as a pusher, sounds weird, as a pusher of messages, and SQS as a queue of messages? Okay. Amazon just kind of threw that in there. I guess they just want you to know about it. It is one of their oldest and most standard services, but we are going to go back to application hosting. So we just spent time talking about virtual machines. Now we're going to talk a little bit about serverless and a little bit about containers, because those are the other 2 ways you can host applications. So if you want to host a virtual machine with an application on it, that's what a virtual machine is for. If you just want to host a process, an application, that's what containers are for. They do still require an operating system, but whether you manage the operating system or not is up to you. Serverless says, I will host your code, but you will not see the operating system in any way, shape, or form, nor can you manage it. So this is where serverless compute services come in, is that this is the most abstracted way to host applications inside of AWS. Now, virtual servers, we stick code on them and they have an operating system on it. With serverless computing, when you hear the words serverless in your mind, you should think hidden servers, meaning you don't manage them, somebody else has them, but they're out there, but you're not managing them. AWS is managing them. Amazon's premier service for hosting just code is called Lambda. This allows you to run code without provisioning or managing servers. But please do not be fooled by this. This has some limitations to it that require you to change the way you think about process workflow and event-driven workflow inside your application. Lambda has a 15-minute execution time, which means at 15 minutes, it's just going to stop processing. So this is not for a 24/7 application. This is for a workflow-driven or event-driven application. What does that mean? Someone hits your website and puts an order in. That order triggers a Lambda, which then goes to the SQS queue, processes the order, and then kicks it over to another queue. That triggers another Lambda to come back to this queue, grab it, and then and so on and so forth. And so what you have is you have a series of Lambdas or serverless functions that make up your application, and none of those are going to run more than 15 minutes. Now, you can chain Lambda functions together. You could say at minute 14, I want to keep going, but I want you to start a new Lambda function. And you can chain Lambda functions together. Don't get me wrong. But just know that it does require just a little bit more knowledge and architecture in order to use Lambda, because it's not just a matter of like, hey, we were running it on a virtual machine. Let's just run it in Lambda. Doesn't work that way. Just want to make sure we're clear. Now, if you were in containers, it would work that way. Hey, we're running on a virtual machine. We want to stick it in containers. Guess what? That's pretty easy to do, right? Lambda doesn't work that way though, right? So serverless is a little different than containers. So just to make sure, serverless and Lambda are for event-driven architectures. That is an official term. It is a way of designing your applications. Event-driven architectures. Tons of great information out there on it. By the way, if you just want to run a one-off piece of code, Lambda is awesome too. As long as it doesn't run more than 15 minutes, or you can chain it together, a great option. All those cron jobs you had running on a single server, they were in Perl and Python and whatever JavaScripts. You can just run that in Lambda. Don't worry about it. Here's how this works. Upload your code, set a trigger event. In other words, what's going to cause Lambda to run? Is it because someone uploaded a file to an S3 bucket? Is it because you pushed a button? Is it because an EC2 web server put something on an SQS queue? Whatever the trigger is, it doesn't matter. The code's only going to run when it's triggered. So for example, let's say you got a web server and it puts 1,500 messages onto an SQS queue. That's going to trigger 1,500 Lambdas. In other words, the cool thing about Lambda is since you're not managing the servers, you don't have to worry about the scale. I mean, don't get me wrong, every account has a maximum number of Lambdas that can run concurrently. I think it's 1,000 by default, if I remember correctly. But you can up that to 10,000 if you want to. You just got to talk to Amazon. In other words, you could have 10,000 simultaneous Lambdas running per second. You probably go even higher if you really get creative around it. So just remember, a Lambda is functions as a service. 15-minute maximum execution time. It supports like Python and .NET and Java and PowerShell and a couple other languages for runtimes. You only pay for when that code runs. If it's just sitting there listening for an event, you don't pay for it. If it runs in response to an event and it costs you half a second, you're going to pay for half a second's worth of execution time. Lambda in general is really, 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 really cheap. But if you run it 24/7, I can start to shift. Okay. Good. Okay. Any questions about Lambda as the serverless way of hosting applications that can run under 15 minutes or less, or that can be, event-driven triggers? Okay. Well, then let's talk. We talked about the most control with virtual machines as far as application hosting. We talked about Lambda, which is serverless, where you have the least control over your environment, but more abstractions. So you don't have to worry about your servers. Let's talk about the middle tier called containers. Containers. So Docker containers, Docker, right? Podman, Builda, there's all these other ones out there. Docker, when someone says the word Docker, what they're talking about is they're talking about containerization. What is containerization? That is nothing more than application virtualization. They're just taking a process, they're putting a standard wrapper around it, and people are interfacing with that wrapper to run the application. That's all that's happening. Containerization, by the way, has taken the world by storm. It's probably the single most disruptive technology in the last 5 years, and it's pretty much taking over everything. Oh, sorry, let me back up for a second. Matthew, you typed a question. Is this considered a SaaS, software as a service? You mean the Lambda stuff? Yes. If you're asking about Lambda, it is definitely a SaaS. It is the highest level of abstraction. So if infrastructure as a service would be a virtual machine, platform as a service would most likely be a container, software as a service would be Lambda. Yeah. So back to containerization. So when we typically run containers, what we're doing is we're putting them in this specialized format. Then as long as we have the containerization software, we can then run the application. So like, for example, in this case, this is a container. And then I'm going to use a different color for this one. And then this is a container. What's missing from this little diagram, just to say this, is that there should be a little like software layer here that contains the containerization software that sits on top of the operating system. And so as long as you have that containerization software, that little green bar at the bottom, you can run those containers on any similar operating system. In other words, all the libraries and everything you need to make that application portable is contained in that either red or green box around those applications. So think of containerization as a way of packaging your application to make it portable so it can run on any similar operating system without the need of any dependent libraries or anything. That's all a container is that's just packaging an application to make it more portable. That's it. Here's the problem. Think about shipping containers, right? Shipping containers, you don't care if there's computers or tires or monkeys inside of the shipping containers. Well, I would care if there were monkeys inside shipping containers, but you don't really care because there's the rectangular boxes, and we see them on the back of trucks. We see them in shipping yards, right? And as long as you have the cranes and the infrastructure to deal with those rectangular boxes, well, then you know what to do with them. But here's the problem, and we have the same problem with our supply chain in the real world, right? Let's say that you are wanting to run this not just on one little ship, but you want to manage it for thousands of ships. In other words, you're going to run containers on thousands of ships. You're not going to run it on one ship. Well, this is where things get weird, is that you need a service to manage these containers for you. And it's called container orchestration. That's the general concept of, like, if I have 5,000 Docker containers, how am I going to run it across 100 hosts? Who's going to do that? Am I actually going to place those containers on each host? Who's going to keep track of them? What if one fails? How am I going to restart the process? In other words, the answer to those questions is that Amazon has two services, one of which is proprietary. Ooh, let me get rid of my drawing. One of which is proprietary to AWS, which is the ECS service, the one on the left, and the one on the right, which is an industry standard service, but it has a lot more complexity to it. The one on the left is, like I said, Amazon proprietary, but it's a lot easier to use, and it really is just there for when you just want to run containers. The Elastic Kubernetes service is a lot more complex, but it matches the industry standard Kubernetes distributions and allows you to use the tools that you use in your private data center for Kubernetes with your public data center for Kubernetes. It is also worth mentioning that if you've ever heard the words OpenShift, which is actually done by IBM/Red Hat, both on all the cloud providers, OpenShift is a first-class citizen. So there's also another option, which is managed OpenShift. OpenShift, though, is a little bit more than Kubernetes. So that's why they don't typically stick it in these slides. But OpenShift is also an option to run containers on this infrastructure. Now, this is how you run containers, which is not running virtual machines. But just to say this, containers require virtual machines to run. And so both of these have an option for what they call EC2, where you actually have EC2 virtual machines running underneath them. Both of these ECS and EKS services also have an option called Fargate, where it's completely serverless, which means AWS manages it and you never see the servers. So just know that both ECS and EKS have a serverless option that's called Fargate. Why did they call it Fargate? I don't know. Why didn't they just call it serverless? Doesn't matter. When you see Fargate, think serverless. Okay. So when they say, hey, I'm running it, ECS or EKS in Fargate mode, what they're saying is they're running it in serverless mode, which means there's an EC2 mode. Okay. In Fargate mode, there's no servers to manage. You still run containers, but you don't see the virtual machines that are underneath them. Okay. Good. All right. Any questions about SNS, SQS, Lambda, or ECS and EKS? If you're looking for the next ecosystem to really understand and you're involved in some kind of delivery of applications, then I'm just going to say this, is that container orchestration is the thing, right? Even as a developer, right, or a data scientist, you're still going to have to deal with containers and container orchestration, because most of the modern, for example, MLOps, machine learning platforms now, are using Kubernetes as their underlying premise. So just be aware. This is where everything's headed. It's containers and container orchestration. Okay. Knowledge check. Sorry. I knew that was coming. I just didn't know when. Okay, here's the knowledge check. Question number 1. Customer wants to use an Amazon EC2 instance for a batch processing workload. Which of the EC2 instance types should they use? If they're going to do data processing, which is a CPU intensive process, which of these drive letters are they going to use? Good. Yeah. Batch processing is compute intensive. Compute optimized is going to be your options. Your main option. Okay. If you're using one of the 6 licensing types for EC2 and you're using reservations or reserved instances, what are the 2 durations you can choose to get the discount for? That's right. A and C. Good. That's same for compute savings plans as well, right? 1 or 3 years. Excellent. All right, customer has a workload that will run for a total of 6 months and can withstand interruptions. What would be the most cost-efficient Amazon EC2 instance purchasing option? Good, you keyed in on it right away. It says it can withstand interruptions. Now we know they're talking about Spot. Okay. A customer wants to give users messages for specific topics to which they have subscribed. Which service governs pushing to people who have subscribed to their topics? Good. Yeah, SNS. Good deal. Okay. So in this module, we went over EC2. I gave you a couple of websites for EC2. We talked about the EC2, like general family types as far as like storage optimized and accelerated computing. We talked about autoscaling and load balancing, where autoscaling is about adding and removing instances based on performance and capacity. And then load balancing is about, basically load distribution or network distribution across a bunch of systems. And then we talked about SNS and SQS, and then we talked about Lambda, and we talked about containerization. All right, as bonus points, what are the 2 short name acronyms for the 2 services that host containers in AWS? They both start with elastic, so it's E something service and another something service. Good. Yeah, so ECS and EKS, right, are the 2 acronyms. Well done. Good. Questions of any type? Okay. We're going to talk about AWS's global infrastructure, and then we're going to take a short break. Then we're going to talk about networking, which they go hand in hand. Okay, so let's say that someone is running a parade around your infrastructure. So that's interesting. They got a parade around your coffee shop, and people are trying to get to your coffee shop, and you're like, what do we do? Right? Well, what happens is that you just run other coffee shops, or you've basically got other like miniature copies, because maybe you have like a coffee food truck, like a coffee truck running around, right? Now, this is where AWS wants you to run servers and services that are either already globally supported or that exist so that your virtual machines can, you can have 2 or 3 or 4 virtual machines running in different locations. Let me give you an example of what I'm talking about. So let's say we wanted to go take a look at an infrastructure map of AWS locations. All right, so here's an interactive map of AWS's global infrastructure. Now, notice that there's blue dots down here and there's orange dots down here. Orange are pending, blue are actually up and running. If we were going to go up into Canada, notice that when I hover my mouse over Canada Central, it says that it was launched in 2016 and that there are 3 availability zones in the region of Central Canada. What this means, by the way, is that there are 3 clusters of data centers inside of Canada Central that make up the region of Canada. So if I go to the console, see how it says Ohio up here? If I click on this and I'm like, you know, I really actually need to be in Canada. Notice it says Canada Central, CA-Central-1. If I click on this, it's going to say, hey, you know what, Michael, you don't have any instances. There's no virtual machines running over here in Central Canada. But if I go back to Ohio, you know what it says? It says, hey, you don't have any running instances, but guess what, Michael? You've got 2 stopped instances sitting here. Right? If I switch over from Ohio over to Northern California, it should say there's no instances here. If it doesn't, then I might have bigger problems. But there's no instances here. If I go over here and switch to North Virginia, another region, by the way, notice there's no instances here. So let's go back to Ohio for a second. Now, notice that the short code for Ohio is US East 2. And that there's a C on the end of it. This means that I'm in the 3rd cluster of data centers inside of US East 2, because A, B, C is the 3rd, right? So I'm in the 3rd cluster of data centers. So in this 3rd cluster of data centers, this is where my virtual machine lives. If that said US East 2B, I would be in the 2nd cluster of data centers. If it said US 2A, I would be in the 1st cluster of data centers that's in Ohio. But I'm in US East 2C, so I'm in the 3rd data center cluster in the region of Ohio. So regions are comprised of 2 or more availability zones. And so availability zones are nothing more than data centers, clusters of data centers, where anything with a network card has to run. So if you start a virtual machine, which has a network card attached to it, it's going to sit inside one of those data centers. It has to. Doesn't have an option. Why? Because it's a virtual machine, which means it has to have a physical location to operate out of. Whereas other services like DynamoDB or your username and passwords may also have a physical location, but it's being replicated across 4 or 5 different services, different locations. Okay. And so that gives you an understanding of this interactive map, which here's Canada. Here is Stockholm, which has 3 availability zones. Here's Tokyo, which has 4 availability zones, plus it has what are called 2 wavelength zones, which we're not going to talk about. And let's see. Notice over here, we got Virginia, and Northern Virginia has 6 availability zones, as well as a bunch of local zones and as well as a bunch of wavelength zones. Just ignore that. I'm not going to explain what local zones are just yet, but I'll get there. Well, Sabrina, just to say this is that every availability zone actually is multiple data centers. That's why I call availability zones as clusters. It's a little weird, but they have multiple data centers that make up an availability zone, and there's multiple availability zones that make up a region. So that's why I say it that way. And don't get me wrong, that cluster of data centers that makes up an availability zone, they are very tightly coupled together. Power is coupled, networking is coupled, but there are distinct locations inside of those data centers. So that's why we typically call a region to be a meta cluster, like a cluster of clusters, if you will. And an availability zone is a cluster of data centers because it's usually not just one. So in this particular case, I can actually deploy an application in Canada and in Virginia if my customers are all on the Eastern Seaboard, or if I've got customers in, the Eastern Seaboard and Tokyo, then maybe what I do is I launch it in, Tokyo or Osaka instead, or I can locate it in Northern Virginia or in Canada. Here we are exploring the AWS infrastructure. That's what we did. Now, there are 4 considerations for why you might want to pick one location on this map over another. Okay. One is legal compliances. Maybe you can't operate outside of the United States. So you're not going to go outside of the United States. You're not going to go outside of GovCloud or Canada Central or Oregon. You're not going to leave. Second reason is because of proximity to your customers. If everybody's in North America, then don't run your data center in Europe. That's not going to make any sense. Other one is the service available within your region? Now, just to say this, most of the new services either come out in Virginia or they come out in Oregon, because that's where Virginia has the most infrastructure and Oregon is closest to where Amazon lives at, like AWS, Seattle, right? So everybody else is going to have most of the core services. In order to find out what someone has, you have to look at the AWS service availability map. This allows you to see which services are available, right? So for example, let's say you really, really love the Elastic Kubernetes service. What you can do is you can scroll down here and look for the Elastic Kubernetes service. Where are you? Let's look for Kubernetes. There it is. Notice that this is available here. But let's go to GovCloud. There it is. GovCloud, let's say East. So the Elastic Kubernetes service is available in GovCloud East as well, right? So just know that you might have to search here to look for services, but most of the time, if you're using core services, they're available everywhere. If the service is 2 years old, it's typically available everywhere. General rule of thumb, right? Now, the one over on the far right-hand side, which is arguably the most important to choose your location about where you're going to host your data center services, right, is pricing. Because just so you're aware, California is like 10 to 20% more than other regions in the United States. Tokyo used to be that way in Europe, and I think Germany used to be that way in Europe. So check your costing. By the way, just to put that in an example, if we go look at the AWS Simple Monthly Calculator, which is a tool that's used to calculate, like estimate like what things are going to cost. If we click into this, notice in the upper top side, it says Virginia up here. Let's say I switch that to Ohio. If I run a Linux on T3 2x large, it's going to cost me about $243 a month, right? So let's get rid of this thing. $243 a month. Notice that I went from 243 to 290 if I run it in California. So notice I'm now in California and I'm now paying $47 more for that same box. That's almost 20% increase. This is a Simple Monthly Calculator, by the way. Great little tool. They are trying to retire it, but nobody wants to let it go. It's like Rick Astley. Wait, I think we actually want to let go of Rick Astley, but regardless, they're having trouble getting rid of this because people love it so much. So security compliances, proximity to your customers, availability of services, and pricing are the reasons why you would run your virtual machines in or regional services in one location over another, right? So just consider that. The Amazon has regions. Regions are comprised of availability zones that sit inside the regions. Just know that some of them are more expensive than others. Here's another example of availability zones sitting inside of Northern California. Notice that this is US West 1A, US West 1B, US West 1C. And yes, Virginia, which has 6 data centers, goes all the way up to D, E, and F. Keep that in mind. This just shows basically is that Amazon, as part of their best practices, asks that you run, if you run web servers, run them in 2 availability zones inside of a region. In other words, run it in an A data center and a B data center, but don't run everything in the B data center. Split it across 2 availability zones. When Amazon has a failure, right, they are going to fail along an availability zone, not an entire region, typically. Let's see, Heather, does AWS weigh into these decisions about where to launch, or they leave it to the requester or the user? Heather, they leave it to the requester or the user. In other words, they'll ask a question, but they won't necessarily say, hey, you know, you've already got 1,000 boxes in one availability zone, you've got 5 in the rest. Are you sure you don't want to switch it? They don't qualify to that extent. Oh, Nathaniel, absolutely. Amazon doesn't know what you're doing with your architecture. So they don't know if there's might be situations where you're forcing it all to be in one data center, but they'll typically say, hey, best practices to run it across 2 data centers. Are you sure that's what you want to do? They typically will ask the question, but they won't stop you from doing it. You can still, Amazon will let you, in a sense, to borrow a phrase, shoot yourself in the foot if you want to. So. Yes, it's the cost of freedom. Yeah. They do have a well-architected framework, by the way, which they'll ask you questions about your workload to raise awareness about, like, hey, are you sure you want to run all your web servers in one location? But they won't force you to do it. Okay, so what is the relationship between availability zones and regions? What's the relationship there? One goes inside of the other. Which is the bigger unit and which is the smaller unit? That's right. Regions are the bigger unit. Availability zones are the smaller unit. Good. Okay. Now, that's all within Amazon's data center, but as you know, everything happens across the internet. So how do we get our data closer to the users if we're like a global shop, as an example? Well, the answer to that is that, let's say we have a single home-based coffee shop located in New York. We got customers all over the world. Well, we do what all good capitalistic franchises do. We start expanding out to other locations, right? In other words, we start putting coffee shops, or at least a copy of the coffee shop, in other locations. Well, Amazon has a service called CloudFront that does the same thing. It basically allows you to put a copy of your static content, whether that's a video file or an image or a website, and you put a copy of it out in another location. Now, don't be fooled by this single edge location. There are 300 edge locations all over the world where you can actually stick copies of your static content. And Amazon will do that for you automatically. You just have to turn it on. They call it creating a CloudFront distribution. This is not an Amazon specific concept, by the way. Content delivery networks have been around forever. Akamai, Cloudflare, Fastly, those are all content delivery networks. So here, a customer is actually going through the edge location to get a copy of the original file. So the customer is actually talking through one of Amazon's servers across Amazon's private backbone to get back to the source to get that file. They're actually, and then the second and third customers who come and talk will actually go from the edge location. They will not go all the way back to the EC2 instance to get the file. CloudFront does cost extra, Brandon, and it's basically done on network transfer, but they don't charge you if they pull data off of your systems. They only charge you if you pull data off of CloudFront. So CloudFront definitely costs extra. By the way, you might say, well, Michael, what if I don't want old content on my servers? You get to specify how fresh the content is, and you can also bust it. You can expire it. So that if you're like, oh my God, we just rolled out a file that isn't supposed to be out there. That's version 3, I need version 4. You can bust the old version and make it disappear if you want to. Okay, so CloudFront gives you edge capabilities, and there's a bunch of other things that CloudFront can do, but we're gonna leave that alone for the time being. That's more advanced topics. So we were talking earlier about all the physical locations for how stuff can run inside of AWS. So remember that some services are availability zone specific, some are regional specific, and some are global. There's only a few that are global, but some of them are global services. So for example, CloudFront, which actually runs outside of AWS's core network, that's a global service. So it matches what you would expect. Now, let's say that you're like, man, I really like Amazon's like management tools, and I'd like to use their management tools, but we got to run it in our data center. Is there any way that I can run the coffee shop inside of my factory, inside of my data center? And the answer is, of course you can. We've all seen Starbucks inside of Kroger's or Walmart's or whatever. We've seen that, or Target's. So Amazon has a product called Outpost. By the way, all the cloud providers have a product that's similar to this, right? Where basically you run like Amazon hardware inside your data center. So it allows you to run their hardware in your data center and manage it from the public web interface, which can be useful. So you get to have that stringent security requirement of having it be in your data center, but it's controlled and managed with the same tooling you use for your public cloud infrastructure. It's kind of nice. Okay. Someone give me one of the 4 reasons, or all 4 of them if you want to rattle them off, of why you would choose one particular region over another with AWS. I'll take one of them off your plate. Service availability. We'll take that one off your plate. So there's only 3 left. What are the 3 other reasons to choose one region over another? Pricing is one. Good job. Compliance, legal compliance, security compliance, yes. And then proximity. Sabrina, good. Yeah, so proximity to customers, that's the key. Okay. Here, by the way, we got a customer. We're gonna run our stuff in a local region. That region's we're gonna run our servers inside of an availability zone in the Sao Paulo region. We're gonna leverage the local edge servers, the CloudFront servers, to make sure that any customer is gonna actually hit that cached content first. And those edge locations, by the way, exist anywhere there's a major ISP. So just be aware. If you have a major internet service provider inside of a country, Amazon has probably talked to them, has probably put a set of servers there. Okay. Now, we're going to talk about how you interact with AWS, but I'm just going to tell you, this next slide is a little confusing because there's really only one way to interact with AWS, and that's to talk to the AWS API. But here is the catch. There's actually 3 different vehicles to talk to AWS's backend. One is through the web console, which you saw me earlier. I was clicking through the web console. Another one is through the command line, which looks like this. Let's bring up Bash. Hello, Bash. For those of you who just missed the terminal, there's an AWS command. This, by the way, is going to describe the instances that I have running inside of Ohio by default, because I didn't actually put a region name on there. So that's one way to do it. Another way is to actually write code, which I'm not going to show you because, well, why? It's melt your brains, melt my brains, right? Not because I'm not a coder, but like, you know, do we need to be looking at Python? .NET, Python, Ruby, C#. There's software development kits for almost every major language, PHP. So just know. These are the three ways that you talk to the API: a web-based console product, a command line-based console product, and then the software development kits, which is another product you can use to import it to. By the way, you don't need to use the software development kit. If you're comfortable reading all the documentation and writing your own logic and back off, you can write your own interface with AWS. So you don't have to use their software development kits. You can write your own if you want to. Okay. We looked at the management console earlier, so we're going to skip that one. Okay. Which of the following is true for the AWS global infrastructure? What is true about the relationship between availability zones and regions? Someone give it to me. That's right. Good. A region does consist of 2 or more availability zones. Remember, a region is the big one and AZ is the small one. Okay. Which factor should be considered when selecting a region? There's actually 2 here. The one that is missing is pricing and service availability. Good. A and B. Which statement, sorry, I kind of glossed over that. Compliance with data requirements in proximity to customers. Yes, those are the 2 options. Remember, pricing and service availability are not listed here. Which statement best describes CloudFront? What is CloudFront as service for? I said this was an industry standard service, but CloudFront is AWS's proprietary version of it. Doesn't do hybrid cloud. It's not a serverless compute engine for containers. It doesn't allow you to receive messages between software components. Looks like D is the winner. Good. Which site does CloudFront use to copy cache copies? Which physical location? Which type of physical location does Amazon use to cache copies of content for faster delivery to users? Good. I see some A's. The edge location. That's exactly right. Okay. What actions can you perform with AWS Outposts? What is this going to get you? That's right. It's going to extend the AWS services into your on-premise data center. That is exactly correct. Okay. So in this module, you learned about the 3 kind of general 3 locations out of like 6 that Amazon has: regions and availability zones, and then edge locations. There are other locations, but they're very specialized, so don't worry about those. 4 things to think about when selecting a region, and then you learned in general about the 3 ways to interact with AWS. Questions of any type? Okay. So here's what we're going to do. It's 11:06. I know we're going to take a lunch in a minute, but we just want to make sure we get a little break. So I want you to come back in 10 minutes at 11:26. We're going to take short 10-minute break. We're going to speed run for like 45 minutes, and then we're going to take lunch at noon. Just want to give your brains just a little bit of a refresher before we start talking about networking. Okay. So come back in 10 minutes. Okay. Let's talk about networking. Da, da, da. Questions of any type while I'm pulling up networking. Okay. Okay. All right, for the next 45 minutes, I'm going to regale you on a sordid tale of connectivity and IP addresses. No, we're going to talk about some fundamentals around networking. They all work remarkably similarly, but AWS has some basic networking concepts such as, subnetworks, private public subnets, how to connect external networks in, such as using VPN or direct connect, and then defense in depth and some of the services that AWS uses to support networking. Okay, so you're in the coffee shop. You realize that cortado that you've been desperately seeking all day long, you want to jump the line because there's 5 people ahead of you. And so what happens is you go and talk to the barista directly. And then of course, they're like, hey, don't talk to the barista, you gotta talk to us, right? And so, because typically the workflow is that you talk to the cashier, they pay for the order, place it, barista makes it, and then the barista talks to you and says, hey, your order's up, right? So how do you scope that workflow so that when you're really hungry for a cortado, you don't jump the line and talk directly to the barista, disrupting the workflow? Or maybe it's a little more maleficent and you're trying to disrupt them on purpose, right? How do we support that from a networking perspective? Well, Amazon likes to create these sub-networking segments or networking segments inside of your account called VPCs. Virtual private clouds allow you to create a network segmentation inside your account. Now, I say that because you used to be able to just run networks without running VPCs, but now you actually have to use VPCs. This was like 10 years ago, by the way. Any account created prior to December 2013 had the ability to actually run networking in what they call EC2 Classic, and you didn't have the ability to run stuff. You could run stuff outside of a VPC. Now you actually have to create a networking pie in order to run your virtual machines, and those networking pies, those segments, are called VPCs. Now, this allows you, by the way, to run subnetworks inside of that pie. You could have slices of your pie, if you will, and one slice can be for public consumption and another slice can be for only private consumption. In this particular space, you can see it because you can have public subnets which run, for example, your web servers, and you can have private subnets which run, for example, your databases, which you never want on the internet, typically. Now, in order for all of this to work, at least for the public subnet, you have to be able to get to and from the internet. And let me say to and from the internet, there are firewalls here. So this is not unprotected access. But I just want you to know that in order for this to function, you have to have a component called an internet gateway. The internet gateway allows you to get to the internet on your public subnets, and it allows the internet to get to you, remembering that there are firewalls in place, so nobody gets to do anything without you opening up the firewall. By default, by the way, the security group firewall is always turned on for every EC2 instance, and nobody can get to your EC2 instances unless you say it's okay. Okay? So by default, you're locked down from the internet. The internet gateway is attached. There's only one for every single VPC, but for every single VPC, there is an attached internet gateway. That is a virtual device, meaning it's not a single point of failure. It's actually many devices hooked up to your network. And I don't know that I found the upper limit for an internet gateway. It's probably terabits. I haven't found it yet. Now, that's all if you want to talk to the internet and you want the internet to be like your communication point. Let's say you don't want to talk to the internet and you want to talk to your corporate network. Well, instead of using the internet gateway, which is a public gateway, you can use what's called a virtual private gateway. The virtual private gateway will allow you to talk to your corporate network over the internet using what's called VPN. Now, you all work for Booz. is there anyone who doesn't know what VPN is? Because if you don't, I will gladly explain it, but I would also be shocked because you all work for Booz Allen Hamilton, and I think you all have to deal with VPN on a daily basis. Nobody, how come no one from Booz ever takes me up on that? You all seem to know what VPN is, right? Yeah. So basically what happens is that obviously you know that you have to connect to some servers across the internet. So if you're at home or an internet cafe, you have to connect because that encrypts your connection and makes it secure across the internet. Now, if your internet connection is slow, then your VPN connection is going to be slow. Just, you already know that, but I'm just telling you, you probably are aware. So if you don't like to run your private encrypted connections over the internet and you need a dedicated, like very privatized pipe, instead of running a VPN connection, you can do what's called a direct connect connection. And with a direct connect connection, you're actually running a cable from Amazon from an Amazon partner to your data center. So it's literally a physical wire. Now, these can come in 1 gigabit, 10 gigabit, and 100 gigabit connections, but this allows you to run your like traffic, if you will, to your private subnets between your corporate data center across a private wire. It's not the internet. It's your own private little pipe, your own private little wire. So if your connections need to be dedicated just to you, and you want them to be private, no, you're still going to have to encrypt them. Just so you know, if you want security, you're still going to have to encrypt them because even though they're private to you, it's still running across somebody else's backbone. So be safe, right? But just know that VPN and Direct Connect are two ways in which you can connect your AWS resources to your private corporate data center. Again, VPN runs over the internet using a protocol called IPsec, which has been around forever. Not IPvSec, IPsec. And then Direct Connect is actually a physical cable. Both of them use the virtual private gateway. Do note that Direct Connect can also use what's it's called. I think it's called the Direct Connect gateway. They have their own gateway, but both of them can use the virtual private gateway. Okay. Let's talk about some networking components here. If I want to isolate a database containing customers' personal information, and I want it to be on its own private networking section, which of these am I going to use? Public subnet, a private subnet, a virtual private gateway, or a direct connect? Good. Yeah. So remember, a subnet is a networking segment. So if you want to run virtual machines, they have to sit on a subnet. I probably didn't explain that very well, so I'm clarifying now. Public subnets are for virtual machines that you want to have access to the internet and you want the internet to have access to them. Private subnets are for when you want virtual machines to only have access to either an internal corporate network or they can access the internet, but the internet can never access them. Not without some jury rigging. So private subnet is the answer for databases because you don't really ever want those on the internet. Now, number two, if I want to create a VPN connection between the VPC and an internal corporate network, I have to use this. Which of these options is it? That's right. The virtual private gateway is the gateway to correct, like it's the endpoint on the AWS side for the VPN connection. Good. If I want a customer, which also means internet-facing website, one of the options for getting this done for a virtual machine is what? I see some of you posted it. It's a public subnet. And number four, establishing a dedicated connection between an on-premise data center and the VPC. Well, that's our last option, so that's pretty much the one we have, right? I do just want to mention this. It has not been true for a number of years now, excuse me, that you need to put your public web servers on a public subnet to get internet traffic to get to them. Just so you know, remember those load balancers that we were talking about earlier? Load balancers can be on a public subnet and they can talk to devices that are on a private subnet. So imagine a world where you don't stick any of your virtual machines on a public subnet. All you do is you stick a load balancer on the public subnet. That way you don't have to defend your EC2 instances against attack. You can let the load balancer, which is defended by AWS, handle that. AWS is really good at defending their devices because, as you can imagine, people are trying to get into AWS all the time to steal all of our information. So AWS is really good at defending their stuff. Okay. By the way, all of us at home are running private subnets. We can get to the internet, but the internet cannot get to us. Oh, don't get me wrong. We can punch holes in our firewalls and do all kinds of stuff to make it so that they can get to us. But in general, we are running private subnets. We are not running public subnets, right? At our houses. So, okay. Now that was all like core networking stuff. Let's talk about security. Let's talk about firewalls. Amazon has two different types of firewalls. One of them is stateful and the other is stateless. But here's the cool thing. The stateful firewall is called a security group. It's right here. It actually wraps around pardon me just one second. Sorry. My smart home started going a little crazy. Okay. So where were we? Security groups, stateful firewalls. Every single time you launch an EC2 instance that has a network card attached to it, guess what happens? There's a firewall around it. You can't disable the firewall. You can open it up, but you can't disable the firewall. By default, the internet cannot get into a security group, but you can get to the internet from your EC2 instance. So just know that security groups wrap around every single network card inside of AWS. And by default, they allow outbound traffic. They do not allow inbound traffic. Security groups, by the way, can only can only allow traffic. They can't block traffic. So you can say, look, I want to allow Michael to talk to Gregory, right? And then because we have that permission set up, Gregory can respond, right? So just know that the reason these are cool is that stateful firewalls only require one rule for us to have a conversation. Stateless firewalls require two rules for us to have a conversation. So like if I'm talking to Johnny and he has a rule that says I can talk to him, but he doesn't have a rule that says that Johnny can talk to Michael, then Johnny and I can't talk because I can talk at him, but Johnny can't talk back to me because he doesn't have a rule for that. This is what network security groups are. So network security groups go past the internet gateway and they hit what's called a network access control list. Sorry, not a network security group. This is what a network access control list is. A network access control list is a firewall that sits around the subnet. What does that look like? Well, let me go back to my previous slide and I'll show you. This box in red is what a network access control list controls. This is a stateless firewall, meaning it requires two rules for you to request and another rule to respond. So two rules total if you want to have a conversation. What this means is that when traffic comes in, this is going to be the pink traffic. Why? Because pink is the manliest of colors. You come in here and hit the internet gateway, right? It's going to hit the internet gateway, go across the VPC, and then it's going to have to go across this firewall. Then it's going to have to go across this firewall just to get to that EC2 instance. So if you're paying attention, you have two firewalls you have to cross to get to an EC2 instance. But here's the simple thing. Amazon disables this firewall by default, meaning it's there, but it's allowing all traffic. And that's by design because they don't want you to have to mess with two firewalls in order to get traffic to work unless you actually want the extra security. Because remember, there's security at this layer and then there's security at this layer, but they only have activated the first one, not the second one. If you need the second one, then you can go turn it on. It's real easy to do. So network access control lists are stateless firewalls. Security groups are stateful firewalls. Security groups wrap around an instance. Network access control lists wrap around a subnet. So an entire network gets guarded with a network access control list. So in this instance, for example, what's the difference between statefulness and stateless? Because Nathaniel was asking. Let's say, for example, that I'm the client and I want to go talk to this EC2 instance. The only thing that needs to happen for that to work is that the security group needs to have a rule that says, allow client to talk to EC2.1. That's it. One rule. Why? Because when the client initiates traffic, this rule is going to assume that I want to allow this guy to respond. How is it going to assume that? It's going to track the state of who initiated the connection. And if the initiation matches a rule, in this case, the allow client to talk to EC2.1, then I don't need another rule because it's tracking the state of who initiated connections and who didn't initiate connections. So the security group knows that the client initiated the connection, and I have a rule that says, hey, you can talk to me. So because it's tracking the state, it's going to allow the connection to go outbound because it's tracking who's initiated what. That's a security group. That's stateful, meaning it is full of state. It is tracking state, and it knows who started what conversation. Here's the problem. With a network access control list, let's say the client initiates a conversation and it's going all the way over here, but the network access control list has one rule: allow client to talk to EC2.1. What happens is that when this instance tries to reply because the client has talked to it, it's going to hit the firewall, and the firewall is going to act like it's never seen this conversation before because it's not tracking any state. It's stateless. So it's going to go, do I have a rule that says you can go talk to this guy? And you're sitting there going, but he just talked to me. You just said he could talk to me. But remember, this network access control list is not tracking conversations. It's just tracking communication. So unless I add a second rule, for example, that says allow EC2.1 to talk to client, then once that's done, what will happen is then this traffic can go all the way out and talk back to the client. But if I don't have both rules, because the network access control list is not keeping track of who is talking to who in terms of conversations, it's going to assume that every single sentence that's uttered is a brand new communication, and it's going to evaluate to see if it's allowed. Yeah, it's weird. And I just want to say this is the way this has worked for 30 years. I remember working on Cisco devices back in like 1990s, where I was like, really? I have to put two rules? But I just said it was okay for them to talk to me. And the Cisco technician was like, yeah, but just because you can talk to them, just because they can talk to you doesn't mean you can talk to them. I was like, that's silly. Why would I only want to have one-way communication? That's not even a networking communication. They were like, that's the way it works. I was like, ugh. Anyway, this is why someone invented security groups, right? Way back when, is that these are stateful firewalls. And so if I say, hey, it's okay for you to talk to me, it assumes because it's tracking it, it's going to allow me to talk back to it, right? There's a bunch of networking reasons as to why it is that way. Just know that stateful firewalls require a little bit more horsepower than stateless firewalls, which is another reason why they exist, right? Is that it does require more resources to keep track of everybody's conversations. Sorry, Nathan, that's a good question. So the only extra benefit is the extra layer of security. There's one other extra benefit. So stateful firewalls. No, it's okay. So stateful firewalls basically only allow stuff. In other words, I'm going to allow port 22 to come in from the client, right? But here's the cool thing. Network access control lists can actually deny conversations. You might say, that's a little, what do you mean, Michael? What do you mean deny? So for example, let's say I open the entire internet up to talk to my web server on port 80. So I got all this traffic coming in, right? But then all of a sudden, and by the way, this really happened. A salesperson inside your organization decides that they're going to employ, like, let's say some kind of like click farm. I'm not going to say from where. They decide to amorally and illegally, not illegally, it's immoral, it's not legal. They decide to employ a click farm because you get paid on advertising. And so they decide to employ a click farm, which is a bunch of people in a data center who are just going to go click on your website. And you're like, hey, that's not right. We don't do that. Security groups can't deny that traffic, but what we can do is we can go to the access control list and say, look, if the traffic is coming from this click farm, I want you to deny it. Network access control lists can do that inside AWS. Security groups cannot deny traffic. So if you want to accept a bunch of traffic and then exclude a small portion of it because somebody in Austria has decided that they want to try and hack your web server, you can do that with a network access control list. You can't do it with a security group. So network access control lists can actually block small segments of traffic based on IP addresses or countries or whatnot. Security groups can't do that. Yeah. So that's why we keep them around. So you get a lot more control with a network access control list, but it's a lot more cumbersome. Security groups can do the same thing a lot easier, but you won't get that fine level of granularity that you can get with a network access control list. Good question. All right. Remember, by default, network access control lists are basically turned off. They allow all traffic by default in and out. Remember that by default, because this is a stateless figuring, this is network access control list, right? Remember, a network access control list is going to check both ingress and egress. Security groups are stateful, and they're only going to check if you start a new conversation. If you're part of an existing conversation, which they're tracking, they're going to let you through. But if you try to initiate a new conversation, then you have to start a new set of a rule evaluation. So remember how, like here, it's like, hey, I remember you. You go right ahead. You were just here. I know who you are. They let you in, so I'm going to let you out. Remember that with security groups, they will allow outbound traffic away from AWS by default, but the internet is not allowed into your AWS account by default. So remember, security groups are the ones that lock down inbound traffic by default. They will allow you to go out, but internet cannot come in. Okay. Last few things. Remember, when you're troubleshooting all of this, because I know that's what you're going to do. And when you go home, you're going to be like, I'm going to start an account because Michael was so inspiring. We're just going to sit here and play with this. I'm changing careers, right? No, you don't need to do that. But know that when you're troubleshooting this, the client's going to have to traverse the internet gateway, cross this firewall, all to get to the instance. And when an instance responds, it has to cross this firewall, then it has to cross this firewall, get through the internet gateway, and get back to the client. So there's a lot of moving parts here. Most of the time, they work flawlessly. But when they go awry, you got to look, mainly the two things you're going to look at is not the internet gateway, because internet gateway, I don't even know that I've ever seen an internet gateway fail, frankly. But usually it's a permissions problem in AWS. Either your security group is set up incorrectly or your network access control list is set up incorrectly. Invariably, like 90% of the time, that's the problem. So there you go. Okay. All right, here's a question for you. Which one of these two is stateful, meaning it's going to track conversations? Security groups, SGs, or NACLs, network access control lists? Good. Which one of these is going to allow you to deny traffic, deny IP ranges? Good. Good deal. Remember, one wraps around the subnet, one wraps around the network interface of an EC2 instance. Okay, last few minutes. Let's talk about the global network, because we've been talking about regional infrastructure and availability zone infrastructure, and there's services that operate at both. For example, a virtual machine is going to operate inside of an availability zone. This is inside a data center, inside of a availability zone. But regionally, services like S3 and DynamoDB, those are SaaSes or platform services. They're going to operate in data centers that are at the regional level. But what about the services that operate at a global level? Now, Amazon has one service that I'm aware of that has 100% SLA, and that's the domain name system, right? We all use this every day. When we type in www.imdeeplyinlovewithkittens.com, we're actually asking that to resolve down, right, to a computer identifiable address. This is what the domain name system does for us, is it breaks it down into an identifiable address. So it says, hey, what's the IP address for this company, right? Now, typically that's going to go to a load balancer. It might go to a web server. It could go to a variety of different things. Amazon's version of this is called Route 53. A bunch of companies have it. But basically what happens is that Route 53 is basically their DNS registrar for Amazon. So if you want to register a domain name with Amazon, you can. Easily done, right? So, and by the way, this DNS service combines with other services like CloudFront to control how your users resolve to your applications when it's hosted on AWS. This can be extremely powerful. So Route 53, by the way, has a bunch of options. Like you can like confine people to a country. You can confine people to the nearest data center, to the fastest data center. You can do lots of cool stuff with Route 53. So here is an example. They've got several EC2 instances behind a load balancer, and this is an application load balancer in this case. And Route 53 is running it through CloudFront, which is then in turn is going to the load balancer, which in turn is going to the EC2 instances. This could actually run across multiple regions. In other words, you can set up DNS so that it fails over between one region and the next. You can have it set up so that users in Japan go to the Tokyo data center and users in California go to the California data center. You can do all kinds of cool policies with DNS. I would say that this and the other option would be Global Accelerator. Both of those show up on the exam on occasion, but DNS is the primary service. All right, let's do a quick knowledge check, and then I will release you for lunch. All right. Which component or service can be used to establish a private, dedicated connection between a company's data center and AWS? Which of these can we use? Because I got to tell you, if they listed VPN here, I'd be a little worried, right? Because VPN would be like the other option, but they instead listed Direct Connect, which is where you run a physical cable. Good. All right. Which statement describes security groups? Because they're asking you two questions. One, is a security group stateful or stateless? And two, does it allow or deny all inbound traffic by default? So which of these options is it? Because remember, NACLs don't block anything, so they're turned off by default, right? Yeah, so security groups are stateful, meaning they're tracking conversations, and by default, they will deny all inbound traffic. They'll allow outbound traffic, but they're going to deny the internet from getting into you. They're the firewall that actually protects you when you launch an EC2 instance out of the gate. Okay. Which component is used to connect a VPC to the internet? Something I said was a virtual device. I've never seen the upper networking limit for one. I've never seen one fail. And it's used to connect a VPC to the internet. Good. That's right. Which service? Sorry, did I clarify that? It is the internet gateway. I didn't say that, did I? Which service is used to manage DNS records for domain names? It has the name of the port that DNS listens on in the name. Yeah, Route 53. Okay. I think this is the last question. Which statement describes DNS resolution? In other words, what's the function of DNS resolution? Why do we have domain name system servers? What are DNS servers used for? That's right, translating a domain name to an IP address. That's what they're used for. Exactamundo. Okay, so we talked about core networking, including internet gateways, public and private subnets. We talked about security groups and NACLs. We talked about VPN and direct connect connections. We also talked about Route 53 briefly and just its use as a domain name system. Questions of any and all types? No? Okay. All right, so we've got about 10 minutes before lunch. I think I said it was plus or minus 5 minutes. I think we're going to go plus or minus 2. So here's what we're going to do is we're going to take lunch a little bit early, but we're also going to come back just a little bit earlier. I really like odd times. So at 11:53, we're going to come back from lunch. That is 63 minutes from now. I'm going to stick a timer up, but in 63 minutes, we're going to come back. We're going to continue to storage and database services. We're going to talk about billing and and then we're going to end with some training resources. So if no one has any questions, I'm going to hang out for just a second in case somebody does. Go off to lunch. Hope you get away from your computer. We'll see you in 63 minutes. Okay. Okay. All right, let's get some stuff rolling here. All right, any questions left over from anything that we covered prior to lunch? No. Okay. Let's talk about storage and databases then next. If any questions pop into your head, let me know. Let's talk about them. All right, a couple questions while I'm loading things up. One, what is the most expensive EC2 licensing type that you can use? Is it on demand, spot, reserved instances, compute savings plans, dedicated instances, or dedicated hosts? Yeah, pretty much dedicated anything, but dedicated host is the most expensive one. Good. When we want to create a virtual private network, we have to stick our virtual machines in these subslices of a VPC. What are those subslices called? Those little subs of a network. Subnet, that's right. Good. If I want to run a physical cable from your data center to an Amazon VPC, what's the name of that technology inside of AWS? Excellent. Good. Good, 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 good. All right. If I said that there were 5 family types of EC2 instances, there's compute, there's memory optimized, there is storage optimized, and there's general purpose, which one would you say is missing? What's the one missing that governs GPUs? Accelerated. That's right. Accelerated computing. Good. Okay. We're gonna keep going. All right, in module 5, we're going to talk about storage. And we're going to talk about the 3 types of storage, which are basically block storage, which is like a USB hard drive attached to your system. We're going to talk about object storage, which is like a remote third-party storage system, like almost like FTP servers, or like if you uploaded a file to OneDrive or whatever. That's actually not storage that's mountable inside of your operating system. But now, of course, like Dropbox and OneDrive and those guys have come up with replicatable ways to make that storage replicate to your system. But they're not, it doesn't really like mount as a file system. You have a copy, they have a copy. You keep the copies in sync, right? That's object storage. That's what the simple storage service is. And then we have what we call file storage, which is kind of like attaching a hard drive to your system, except it's actually happening in another server, which then is presenting that drive to you over the network, right? That's called file storage. So we're going to talk about that kind of storage, and then we're going to talk about database applications. And we're only going to talk about 2 types of database applications of the services that Amazon offers. One is going to be a relational database service, which is called RDS, oddly enough. And the other is Amazon's flagship NoSQL service. That's called DynamoDB. So we're going to talk about both of those. And by the way, we're going to just quickly skim through a list of a bunch of other database services. So just be prepared. So I mentioned there was going to be block storage, object storage, and file storage. Remember, block storage is like almost like a directly attached disk. Object storage is a remote storage system that is not mounted inside your operating system. And file storage is very similar to block storage, but the difference is that you're mounting a disk that's on another operating system, like a Linux box, for example. Now, block storage, the reason it's called block storage is that usually a hard drive is broken up into blocks. How many blocks? Depends on how big the hard drive is. But like, for example, blocks could be like 4 kilobytes in size. They could be 8 kilobytes in size. They could be 12, 16 kilobytes in size, or they could be smaller. They can be larger and they can be smaller. What that means is that if you need to store a 13K file and you've got 4 kilobyte chunks or blocks, you're going to need 5 of those because you need at least 13. 4 will only get you 12. 5 will get you 15. Wait, is that right? Yeah, 4K size. No, you need 4 of those. Sorry, my math was off. You need 4 of those. So I guess the point of that is that in block storage, the hard drive is broken up into little tiny little pieces called blocks or chunks, right? And those have a certain size to them. And they are super fast because typically it's like there's like a physical disk and it's directly attached to the system in question. Now, this is Amazon and these are virtual machines, so they're not actually directly attached. So it's not like plugging a USB hard drive into your system. It's more like there's a server that does nothing but pretends to be a USB hard drive, and over the network it plugs into your virtual machines, right? But it does it so fast that it's almost faster than a USB hard drive, like in that case. Now, Amazon has a solution for block storage called EBS. I'm going to skip over that one slide for a second. EBS is called the Elastic Block Store. And Elastic Block Store is the hard drive service for virtual machines, for EC2. So if you need a virtual machine hard drive, you're going to use EBS for that. Now, you could use file storage, but that it's not really going to allow you to boot a virtual machine. And you cannot use S3 to mount inside of an operating system. I know people have done it, but it's not really designed for it. It doesn't perform very well. Now, I say that just so you know, if we go back to our earlier chart, no, not my personal schedule. Let's go to EC2 instances.info, where you may remember that some of these instances, hold on one second. Oh, that's a little, there we go. Some of these instances, by the way, had storage attached to them. You see this? They call that instant storage. This is included with the cost of the virtual machine. I'm going to give you a best practice. Make sure you open your senses and really take this in. Do not use instant storage. Don't use it. Don't use instant storage. In case you missed that, you shouldn't be using instant storage. Don't use instant storage. I'm going to say, well, Michael, hold on. It's free and it comes with the system. Why wouldn't I use it? Well, let's go take a look. Let's say I'm really into the I series because, you know, it's one of my favorites. Really? Oh, you know what? Sorry. I'm kind of messing things up over here. All right, this is the I series. Remember, this is a storage optimized system. Note that every one of these i3 boxes comes with instant storage. It does not use EBS as its like default storage system. Instant storage is storage that is attached to the actual physical hardware that the virtual machine is sitting on. So I want you to follow me because I'm going to draw some pictures up here and it might get pretty annoying. So just bear with me for a second. Let's say I got these virtual machines up here. There's in these little red boxes that I'm drawing up here on the top. And inside each of these little virtual machines are some really awesome fast hard drives like they're listed down here below, right? You got some hard drives attached to the machine, all in green, right? And then I decide that I'm going to launch these lightning fast i3 systems, which are going to use this storage, right? Here's the problem. This storage is only available between these two systems at the time that the virtual machine is started. If this host crashes, guess what happens to that storage? Anyone want to take a guess? That's right, it's gone. Also, if this virtual machine crashes and has to be started up on another system, because that happens more often than you'd like to think it does, guess what happens? That new pink square doesn't have access to the storage because it was over here on this previous system. In other words, it doesn't have access to the storage. It now only has access to this storage. Guess what happens? All your data is lost. So instant storage is great if you're just scratching around, or if you have data that's easily replicated. But if you were actually going to run a database on this thing, you better have a backup system, right? So you might say, Michael, that's horrible. If the host crashes or if the virtual machine crashes, I lose all my data on the hard drive. Yes, that's exactly right. That's why we say don't use it. Just know that it's there. Okay. Don't use it. Unless you really know what you're doing. If you feel really comfortable using it, then go ahead and use it, right? But then you might say, well, hold on, Michael, hold on. Why is EBS better? Well, I'm going to explain that to you. So let's just go down to 2 virtual machines here. So EBS is different. So let me put this into a different color just so you know I'm serious. EBS is over here serving out hard drives on its own separate system. So it's serving out these hard drives that are actually available to these virtual machines. So this virtual machine has access to this one. This virtual machine has access to that one. This virtual machine has access to this one. Okay. Guess what happens if this host goes down? Oh, really? You're not gonna let me click on the eraser? That's weird. If this machine goes away and we restart this virtual machine on this physical host right here, guess what happens? It now still has access to its hard drive. You know why? Because the hard drive is over here on another system. So when you use the Elastic Block Store, instead of using instant storage, your hard drives and your virtual machines are independent of each other. Don't get me wrong, they're coupled, but they're not tightly coupled. If the virtual machine crashes, you can just start another virtual machine and grab your data over on the other side. You might say, but Michael, what if the hard drive crashes? So here's the cool thing about Amazon. Amazon maintains 3 copies of your data at all times, live, like hot. So I've actually lost hard drives underneath the virtual machine and never known it because Amazon runs 3 copies of these little blue drives. They have 3 copies of your data hot at all times. So you really have to like delete it yourself if you actually want to lose data. That's the only way. To date, I've never lost data from a hard drive inside of AWS. I also keep backups in case of corruption. That's a different thing, right? But this is how EBS works. EBS is 2 separate systems. You've got the virtual machine system and you've got the virtual hard drive system. With instant storage, they're on the same system, which means if the host crashes, which they do, and you have to restart that virtual machine, you're going to lose all your data. So just as a general rule of thumb, if someone says, hey, how come you're not using instant storage? You can say, well, because it's ephemeral. It's temporary. It's not meant for permanent long-term storage. It's not meant for persistent data. It's fast. Don't get me wrong. It's super fast, but it is a horrible idea to use this storage. Now compare that with EBS, which EBS is a separate subsystem. EBS, no matter what happens to the virtual machine, your data can operate and exist independently of the lifecycle of the virtual machine. So EBS is the hard drive service. Instant storage is just a little scratch volume that gets attached to some of your EC2 instances. In general, don't use instant storage. In addition, with EBS, you can take automated snapshots using the Lifecycle Policy Manager or AWS backups if you're interested in that. But you can actually take snapshots of your data, back up those hard drives in a regular interval, and you can do that live without impacting the performance of your application, which is really cool. Now, don't get me wrong. If you're writing a lot of data very frequently to a system and you take a snapshot, you might miss some data, but you can also quiesce the application if you need to, pause it for a second, take your snapshot, and then come back, okay? All right, so EBS is block storage. That's directly attached storage. That shows up inside of shows up as a drive letter inside your operating system, right? So just know. So what's the big difference then between EBS and instant storage as I just defined it? What's the big difference? What does EBS have that instant storage does not? Data persistence. Good, Brandon. That's right. EBS has permanence. Instant storage does not. So remember, instant storage is ideal for temporary data. EBS volumes are ideal for long-term retention. Good deal. Okay, now we're going to move on to object storage. Now, object storage is fascinating because this is a remote storage system. It does not mount as a drive letter inside your operating system. The way it works is you have a key, like a name of a file. And when you hit, like ask for that key, it returns the value of the file in question. You might say, well, that sounds like a file system. Yeah, it's kind of like a file system. It's not really a file system, but it sounds like it, right? And so this is what object storage is that when you push an object up there, you can specify the content type. Like, is it a zip file? Is it a HTML file? Is it a Word doc? You specify the content type and you push it up onto basically a third-party server, and it's going to host it. Object storage is great for storing lots of small files in mass, but it's not great for high performance against a single file like a database. So the simple storage service, you store these objects, these files in buckets. You set permissions on the buckets, and then you can actually choose hot or cold storage classes depending on how you want to store these things. Now, S3 has a bunch of storage classes. There's standard infrequent access, which is what that IA stands for. There's one zone infrequent access, which is what the IA stands for, which is a little less redundant, right? Then you've got intelligent tiering, which is an interesting storage class because it actually moves data between the other storage classes. And then you've got two what we call archival storage classes, Glacier and Glacier Deep Archive. These storage classes' sole function is to archive data away. So whereas these three and this fourth one allow you to access files like in real time, these last two, the file is actually stuck in a vault and you can't access it until you restore it into one of these other three options, or four options, I guess. Okay, so know that Glacier and Glacier Deep Archive are like cheap, and they are not direct access storage. They are archival storage. So here's something to be aware of in terms of hot and cold. Standard, like if you want to put a terabyte of information onto standard, it's going to cost you about $23 a month in Virginia. Every time you step down a storage class going from left to right, it usually drops by like a couple bucks, right? So sometimes $6, sometimes $7. When you get down to Glacier Deep Archive, that 1 terabyte of storage, instead of costing you about $24, it's going to cost you $1. So Glacier Deep Archive is literally 1/24 of the cost in Virginia, at least, of the standard hot storage. By the way, they call it Glacier because it's cold storage, right? So, you know. All right. So just keep in mind is that S3 is object storage, and so it's a remote storage system. Now, when you look at it, kind of like looking at Dropbox, just to bring up the web interface for a second. I wonder what I was thinking when I closed that. Let's go to S3 for a second. When you go look at it, it looks remarkably like a file system, right? Like here's BAH admins, which is public. And in here, I've got 2919, which is a class, and here's some virtual machines. Here's, I don't even know why this is here. That's interesting. That's a gaming thing. Static websites, VPCs, that kind of thing. This looks like a file system, does it not? BH admins is the top level folder or bucket, and underneath that looks like there's other folders. And inside these are objects like presentations, zip files, all kinds of stuff. But this is on a remote server. It's not mounted inside of my operating system. If I go look on Bash, which is what we were using earlier to interact with AWS through the command line, just note that if I do an AWS S3LS on the command line, it's going to list those same buckets, including BAH admins, which I was just looking at. So this is on another system, not attached to my box. The other thing you might notice is that, see how this says the standard storage class is standard? This one is set to 1 zone infrequent access. I could probably take some of these and rotate them down to Glacier if I wanted to. We could edit the storage class down, make it Glacier Deep Archive. Save my changes. And basically what it's going to do is it's going to edit that whole file and it's going to put it into Glacier. If I want to retrieve it, I got to restore it. Otherwise, I can no longer access it. See how it says, in order to access it in Deep Archive, you first have to restore it. Right, so I'd have to edit the class and restore it away from Glacier Deep Archive to get it back into S3. Notice I can't edit encryption anymore, right? Or even edit the storage class right now because it's in the middle of transitioning. That's why. So that's what S3 is it's just a place for you to stick a large number of files. S3 has no storage limit. Amazon charges you on a per gigabyte basis and per change basis. But I got to tell you, this is way cheaper than EBS. But whereas EBS is going to give you high performance with one operating system with one disk, S3 is going to can be operated on by thousands, if not tens of thousands of servers simultaneously. But it's really great for writing large numbers of files. So it's a good option. Okay, knowledge check. If you want to store data that's infrequently accessed but must be immediately available when needed, which of these S3 storage classes are you going to use? Good. They're still not explaining what IA is, but I think I told you it's infrequent access, right? If the word says infrequently accessed in the question, that's probably the storage class you're going to use. Okay. Let's move past object storage unless anybody has any questions. Okay. Oh, so Brandon, a real world use case for S3. So S3 is actually the default storage system for almost everybody. Nobody uses EBS first unless they actually have to boot a virtual machine. S3 is where everybody stores their log files, everybody stores their analytics data, everybody stores their reports and shares it out with the world. This, everything from Excel spreadsheets to anything. It's not used for databases because obviously database applications are different. But any in mass like data sets that you want to store, they're typically stored on S3 because they're just cheaper than storing it on a hard drive attached to an EC2 instance. Plus, it's more widely available. So, like I said, log files, batch files, reports, video files, and image files. I once ran an entire company off of people serving their like cat videos, as an example, off of S3. And S3 was the backend source for the file, and otherwise it was shared the world over using CloudFront. So it could be anything, any static web assets like images, client-side JavaScript files, HTML, like flat up HTML is great. S3 can act as an FTP server. It can act as a web server. It used to be able to act as a BitTorrent server, which is something I just found out recently, which I thought was weird. But any large data sets. In most enterprises, what I usually end up seeing is that people using it as a log repository for any logging information, for clickstream analytics. I think these are the main ones I've seen. Sometimes maps, serving any assets of any type, zip files, upgrades, all kinds of stuff. There basically isn't much that isn't stored on S3 unless it's just needed by Windows or Linux as a hard drive. Okay, so file storage is a little different. So, if we look in here on my system for a second, let's ignore quick access. Notice how I have these drive letters. Some of these are direct attached. Some of these are actually like attached across a network. They're actually attached to a server that's on my infrastructure, right? But they look like drive letters. They look like just straight up clean drive letters. And so this is what file storage is that file storage is basically connected across the network. And it looks like a drive letter, like almost like locally attached storage, but it's running on another server, right? This is provided by a service called the Elastic File System, or EFS. Now, just to make things confusing, this is the Linux version. There's a Windows version that's called FSX. Just post that in the chat. So FSX is File System X, and there's a couple of different flavors, but one of them is File System X for Windows. So EFS is for Linux, FSX is for Windows. Those definitely show up on the exam, but what they do is they allow you to share a file system with many different servers across an entire network. So across an entire VPC, across multiple subnets, across an entire region. You might say, well, why would you use EBS instead of this? Well, EBS is faster, EBS is generally cheaper, and EBS only works in one availability zone. EFS, even though it's a slightly more expensive, it can serve multiple systems, but EFS will go across an entire region. So if you have 3,000 servers spread across 3 availability zones, EFS will let you serve all of those servers with a single file system. EBS is one hard drive for one operating system, typically. There are exceptions to that, but typically that's how it's set up. Okay. So that covered block storage, object storage, and file storage. File and block are very similar. The only difference is basically the speed and the availability, whether it's of AZ specific or region specific. Object storage is very different in that it's a third-party system, and you just programmatically either put or retrieve entire files. You do not mount it as a hard drive. Okay. Next is database services, data store services, basically. Now, we've been using databases since the 70s, I think it is, 70s. I don't remember what the first like relational database service was. I'm sure I could look it up. Probably Berkeley DB or something, but that's kind of a file-based system. Anyway, we use these a lot now because MS SQL Server, Oracle, Postgres, MySQL, these are all options. So the world is often divided into 2 general types. There's our traditional relational database services, which we've been using for 30 or 40 years. These are where you got a table, it's got columns and rows and everything's very structured, and tables have relations to tables, you know, right? And then there's a non-relational database where you've got like a key, like, you know, song title. And if you retrieve the song title, you'll get a blob of information about the song, including artists, year published, all of it. But it's not in a row and column format. It's like once you get the key, you get all the data back. Now you can filter it, but generally you're going to get all the data back in one big blob. So with relational databases, data is stored in a very structured way where pieces of data have a strong, tight relationship with each other. And the schema or the structure of that data is very clearly defined. When you use this, when you need an like structured query language, or when you ever need to like strong consistency in your system. And this is where the relational database service comes up. Amazon has a relational database service. It has a variety of different flavors. There's Postgres, MySQL, Maria, Oracle, and MS SQL. Aurora is Amazon's special flavor of Postgres and MySQL, which is 3 to 5 times faster than the same data sets on the same servers. It's way faster. It's really cool, actually. Aurora basically is a cloud modernized version of our traditional open source database technologies. The only other thing that I'll tell you about Aurora that is incredibly cool is that it has a serverless version. So with the rest of these, you need to actually t-shirt size these with special EC2 instances. you can't log into the EC2 instances, but you have to declare your capacity for your database by choosing this instance. With Aurora, you can do the same thing, or you can go serverless, which means they handle all that for you. You just run your queries and they scale as you need to scale. And it's pretty nice. Hold on just 1 second. Now contrast that with a non-relational database where you put a key in, and the key could be a number, the key could be artist, the key could be book title, the key could be ISBN number, but you've got a single or two singleable set of searchable keys. And when you match those keys, you get a blob of data back or a document back or some kind of match back. So there's lots of different ways to do NoSQL or non-relational databases. But Amazon's flagship service for non-relational databases is called DynamoDB. So if RDS is for relational databases, DynamoDB is for non-relational. This is a serverless key value database. So unlike RDS, which requires EC2 t-shirt sizes underneath it, and so your capacity is limited to the size of the EC2 virtual machine you chose, DynamoDB is completely serverless. So this is automatically going to scale up and down based on what your read and write capacity is. And at the last Amazon Prime Day, well, actually, this isn't even true. In 2019, there were like 10 trillion requests per day, and this thing was handling 20 million requests per second. Now, what's the nature of those requests? I don't know. They could have been very simple, actually. But the fact that a single table was handling 20 million requests per second, it's pretty good. So just remember that the RDS service, the relational database service, is Amazon's flagship relational database service with all your standard open source items. They do have a subflavor of RDS called Aurora, which I mentioned earlier. And then we have DynamoDB, which is this service, which is their flagship NoSQL service. They have tons of other NoSQL services. They've got Cassandra, they've got MongoDB, they've even got streaming, but like analytics engines like Kafka, right? So, there's Amazon tends to take a lot of open source products and bring them in as services. So if they're very popular, Amazon tends to have it. Like, for example, they've got a graph database that's based off of Neo4j. God, what else do they have? They have a ledger database. They've managed Bitcoin, which who cares? Yeah, they got a bunch of other. Oh, Elasticsearch is in there. They have a Solar variant. So in addition to those two kind of flagship database services, they also have a database migration service. So just know that AWS with DMS, they have the ability to move you between a source database and a target database. So the source and target databases can be of the same type, like you're going from Postgres to Postgres, or they can be different types, like going from Oracle to say Postgres or Oracle to like DynamoDB. You just have to read the documentation. DMS, by the way, will do a one-time transfer from your data center to AWS, or it will do a continuous transfer, like it'll keep things in sync, right? Do note that one of the targets, by the way, has to be an EC2 system. Like it has to be going into EC2 or RDS or DynamoDB. Just so there are some limitations. You have to make sure you read the documentation. Okay. So then here is a quick little knowledge check. Where would you use a relational database and where would you use DynamoDB, which is NoSQL, right? If you're going to store data in a relational database, which of those two services you're going to have to use? RDS or DynamoDB, which is usually just DDB? Good. Yep, I'm going to store it in RDS. Okay. If you want a completely serverless database, there's actually two options, but what's the one that predominantly is serverless? Yeah, you have a serverless sub option inside of RDS, but mainly when they say serverless, they're talking about DynamoDB. So perfect. Good. If we are going to be storing data in a key value database, out of these two options, which one is going to be the key value database? That's right. Key value database is definitely going to be DynamoDB. If we have decided that we must have SQL to use to structure our data, which of these two systems are we going to use? Now, just to add some weirdness to this, RDS is definitely 100% the right answer. You can actually, in some cases, run SQL queries against DynamoDB. I know, little exceptions. All right, if you want to scale up to 10 trillion requests per day or 20 million requests per second, which of these technologies do we know for a fact can handle it out of the box? Good. DynamoDB. Number 6, if we are storing data in an Amazon Aurora database, which Aurora is a subservice of which of these two systems? Good. That's right. RDS. Here's other services of honorable mention that you should pay attention to. 1, Redshift is the data warehousing app for Amazon. It's based on Postgres 8.1, although it has evolved mightily since that time. But that's where it originally started. Just know that this is the data warehousing application. DocumentDB is the MongoDB application that I was referring to earlier. Neptune is the Neo4j graphing database that I was referring to earlier. By the way, they call Elasticsearch or OpenSearch. QLDB is a ledger database. Most people don't even touch that. We also have managed blockchain. Just ignore that. And then Elasticache, which is actually based on 2 open source technologies, Redis and Memcached. They also have managed Redis for those who need Redis as its own standalone system. So just know that Elasticache is Redis or Memcached. And then last is what they call Dynamo Amazon DAX, which is the DynamoDB accelerator. This crazy read-only like caching mechanism will sit in front of your DynamoDB database and will get you down to to microseconds of speed. It's crazy. So if you need microsecond response times, then DAX is going to be your friend. Okay, quick knowledge check across the entire module. 1, which S3 storage classes are optimized for archival data? What are the 2? Good, B and D. Remember, Glacier, right, is the only archival system. So if it's a Glacier Deep Archive, that's what we're talking about. Okay, what is true about EBS volumes and EFS file systems? In other words, which of them will only present data across a single availability zone, and which of them will present data across multiple availability zones? That's right. EBS is only a single availability zone, because remember, that's a hard drive service. It's 1-to-1. EFS will present file systems, network file systems across a bunch of servers. That one is designed to be multi-AZ or regional. Customer wants to store data in an object storage service because they have thousands of log files, if not millions. Which AWS service do they use to store a large swath of files? That's right. This is an S3 Perfect use case. Okay. Which statement describes Amazon DynamoDB? Yeah, the other ones all contain keywords that are kind of no-nos, right? A serverless key value database. That's it. All the others have relational in there. DynamoDB is not relational. Yeah. Which service is used to query and analyze data across a data warehouse? Which of these is Amazon's data warehousing service? Excellent. Wow. Okay. That's it. So we just went through, by the way, instance storage, EBS volumes, S3, EFS, and its Windows counterpart FSX, which I just gave honorable mention to. We also talked about the 6 Amazon storage classes. So standard, standard infrequent access, one zone infrequent access, intelligent tiering, Glacier, and Glacier Deep Archive. We finally learned also about AWS database services, including RDS, Aurora, DynamoDB, and AWS DMS. So, you know, we talked about, and we also mentioned Redshift and Neo4j and a couple other things. Sorry, Neptune is what they call Neo4j. Questions of any type around this? Okay. Let's talk about security. And then we'll take a short break. Okay. All right. In this module, which is actually kind of relatively short, honestly, we're just going to describe at a high level a few things about how to, one, log into AWS, because just so you can understand the general concepts. 2, wow, that was an interesting cough hiccup thing. What would happen if you had like 50 accounts that you had to manage and you wanted to enforce compliance among those accounts? And then we'll talk about some AWS security services, right? Beyond just logging in. Here's a few things to be aware of. 1, Amazon has what's called a shared responsibility model. This says that you're responsible for security of things you put in the cloud. Amazon will make sure that the cloud itself is secure. Here's your general rule of thumb. If you can log into it or configure it, you are responsible for both your configuration or the entire thing if you can log into it. In other words, if you can literally log into your operating system, you are responsible for that entire operating system. You control it. If all you can do is flip a few web-based toggles, but you can't log into the load balancer, guess what? You're not responsible for defending the load balancer. If you start an RDS database, you can't log into the operating system. Guess who's responsible for patching the operating system? That would be Amazon. If you do not know physically, you do not have access to Amazon's data center, guess who's responsible for defending the data center? Not you, Amazon, right? So the shared responsibility model says, look, if you can log into it, you're responsible for the whole thing. If all you can do is configure it, then you're just responsible for your configuration. So this is security in the cloud versus security of the cloud. So with that in mind, let's challenge that a little bit. Who's responsible for the security of configuring security groups on your Amazon EC2 instances that you just launched? Who's responsible? The customer or AWS? That's right. You're responsible for configuring your security groups because they're your EC2 instances. You launch them. So you're responsible for configuring the firewalls for them. Who's responsible for maintaining the physical network infrastructure? AWS or the customer? Good. I don't even know where their cables are. So I am definitely not responsible. Oh, you know what? I just gave that one away. So we'll just give that up. Hey, guess who's responsible for doing physical security controls at a data center? Hey, it's AWS. You guys are so good. You got that one. All right. What about patching software on EC2 instances that you launched? Yeah, so if I launch it, I'm responsible for it. You know why? Because I can log into the operating system. I control that entire thing. Amazon doesn't want to be responsible for something that you have access to. Either you have full access and therefore full control, or you have no access and therefore you don't have control. Amazon's not interested in sharing, right? Number 5, maintaining servers that run Amazon EC2 instances. Who's responsible for maintaining the physical hardware that runs the virtual machines? Well, no, don't get me wrong. I'm surprised no one was like, well, Michael, what if I get a bare metal instance? Yeah, sure. But you're still only configuring it. You don't have access to the box. They're responsible for making sure that your hard drives stay up on a box that you've bought from Amazon. So regardless of whether you buy a metal box or whether you're running a virtual machine, Amazon is still responsible for making sure that virtual machine gets or physical box gets serviced. You don't deal with that. They do. Okay, this one shows up in the news all the time. Who's responsible for controlling access to your S3 objects? You or Amazon? Yeah, the customer. And by the way, you may have seen this in my when we were looking at mine earlier. Can anyone tell which of these buckets out here? Oh, really? Is publicly accessible? Someone see a glaring red statement that says, hey, by the way, this S3 bucket is public? If so, what's the bucket name? Type it out for me. Yeah. You have to unclick like 5 things to get your bucket public. Plus you have to apply a special policy. So when people show up in the news and they're like, Chase credit card today allowed 5.3 million social security numbers from their customers to be shared across the internet via S3. I never sit there and think to myself, man, Amazon must be really messing up, because they try to make it so hard for you to do this and not know that you're doing it. So yeah. Notice, by the way, that while objects can be public, this is the only one I have that is public. So. All right. Okay, so now that we covered security, let's talk about logging in. How do we control access? So we got a new cashier who's working at our coffee shop, and we just want them to have access to the point of sale system. We're not going to give them access to inventory. We're not going to give them the keys to the store, right? And even on the point of sale system, we're probably going to not allow them to delete or roll back things, just, execute a customer's purchase. The service that controls users, groups, and passwords on AWS is called IAM. There are 2 types of users. One is the user who created the account. There's only one. This is the Highlander rule. There can be only one. This user should never be used for anything other than creating an administrative user once the account is first created. Otherwise, create your first IAM user, give them permissions, and scramble the password on that AWS account and put it into a break in case of emergency kind of glass box. Don't use it otherwise. Then you're going to log in as the IAM user. You're going to create other users, and you're only going to use that root account, which, by the way, is an email address, to log in if Amazon asks you to, which, by the way, they're not going to ask you to, but they might, but they usually don't. And they're certainly not going to call you and ask you, right? They're going to talk to you inside of your account. Now, to log in, every actual person like me should have a user account called an IAM user. you can actually see mine up here because I am logged in as Spartan Sage, which is my IAM user. That's what my son calls me, Spartan Sage, at M Forrester. M Forrester is my account. So I have a username at an account name. Now, my account number is an alias to M Forrester. And how do I know that? Well, I'll show you. Because I created it. If I go into IAM and I show you the dashboard, hi, what you doing? Notice that I have an account alias over here on the right-hand side, and it says M Forrester. I created that, by the way. You can create your own account alias. As long as it's not taken by somebody else, you can add whatever account aliases you want. So users come with username and passwords. Users come with keys, like API keys that allow you to access Amazon's API. In order for that to work, you have to attach a policy that either allows or denies access to that user. If you tell someone, if you don't actually add permissions that allow somebody to do something, by default, you can do nothing in AWS. It's just like security groups. If you do not actually say, Michael Forrester is an admin on the account, Michael Forrester has nothing. Michael Forrester is a power user on the account. Otherwise, Michael Forrester has nothing. Michael Forrester is a read-only user on the account. He's got nothing. Now, I just did 3 general broad buckets. The granularity by which you can control permissions in AWS is mind-boggling. It's mind-boggling. You can get down to the specific API call that you want the user to have permission to run or not to run. And you can do it on very specific resources. Notice that this policy document is allowing, look at, see the effect? Allow them to either list or get objects in S3. See how it says S3 list object? And then S3 get object? And then only for these specific resources, the example bucket and the example bucket. That's it. That's it. Now, users can have policies attached to them, but groups can also have policies attached to them. This is the way it's typically done. Users are put into groups and the groups have permissions policies attached to them. Why? Because the group names are going to be intuitive. My username is Spartan Sage, but my group names are like, hey, full EC2 access, full S3 access, partial DynamoDB access, read-only, Redshift access. The groups are more intuitively named usually. And so in our previous example with the barista, the cashier is probably part of the new cashiers group, not the established cashiers group. Now, what happens, by the way, if we need to temporarily give the new cashier access to the inventory management system, but just for like a temporary credentials? This is where roles come in. Roles give someone the ability to assume a new set of permissions temporarily. Roles are basically created within an account, and you specify who can assume the role. Let me show you an example, a real world example to make this like work. I have very limited permissions as Spartan Sage. But if I go look under here under roles, I've created a role called, wait, let's be specific. M Forrester admin. Right now, I'm in my demo account. If someone hacks this user, they're not going to be able to do a whole lot. But let's say I need to go in here and change something. If I come up here and I copy my account ID and I click on switch role and I paste my account ID up here, I can actually switch to the M Forrester admin role. When I click on switch role, look at what happens to my username in the upper right-hand side. I am still Spartan Sage. I'm still logged in as Spartan Sage, but I just transformed my security identity so that I am now M Forrester admin, which now means I can go in here and change stuff, including my password. So just know that users get policies, users can be put inside of groups, groups can get policies, roles can also get policies, and roles are just used for the temporary assumption of security privileges. That's all they're used for. So we could give our new cashier, by the way, temporarily an inventory role or a cashier role, just allow them to assume whatever they need to based on whatever role are happening. And we can make it so they can only assume the inventory role that day. They can't use it any other day, right? Now, in addition to users, groups, and roles, one security enhancement is that you can actually turn on two-factor authentication. You actually saw me using that earlier because I had to put in that code before I logged in. You're familiar with two-factor. If you're not, please let me know. But we enable it on almost every website we're in because that way you have something that you know, which is your password, and something you have to have in your possession, which is your hardware key or your phone with a software key on it, right? That's why we have multi-factors. It's multiple factors. Other factors could be biometric factors, like, you know, having an eyeball or facial recognition, right? Somewhat sketchy in today's age. Okay, that was all just about getting logged into a single AWS account. What if the problem is that you have to manage multiple accounts, not the logins, but let's say you're managing multiple accounts and you got to control those accounts. And I say that like we need to control the world. We don't, but there are certain limits, right? You don't want everybody running the quantum computing service, do you? Unless you're in the quantum computing business, and that's a whole different conversation. So then how do you control a bunch of accounts that are under your oversight? Well, this is where organizations comes in. Organizations allows you to put a bunch of accounts under what they call service control policies. Now, service control policies can only deny access. They can't grant access. So someone in the account still needs to give people access. But you can come in and say, look, I don't want any one of the 50 accounts that I oversight. I don't want any of them running quantum computing. I don't want any of them using the gaming servers. I don't want any of them using managed blockchain. So they call them service control policies, but they allow you to basically externally block which services people shouldn't be using in your entire organization. Now, don't worry, people can come to you and say, hey, can I get an exception? And you can put them on an exception list. That's not an issue. One other thing that happens with organizations is all the billing gets consolidated into a primary account, which is super cool because you then start getting economies of scale, because if everybody's using a terabyte of S3 and you've got 12 accounts, you just crossed over the 10 terabyte threshold, which means the next 2 terabytes, because you got 12 accounts, right? Terabyte a piece, 12 terabytes. The next 2 terabytes are going to be cheaper per gigabyte because you aggregated all your usage into one volumetric discount. So consolidated billing is another benefit of organizations. Here's an example, by the way, of having like a root account. And notice there's a finance account, there's an IT account, there's HR, there's legal. And what happens is that you can create different organizational units that have access to different things. So notice the IT and the finance account have different levels of control and policies than, say, the HR and legal account. Okay, knowledge check. Customers configuring service control policies in organizations. To what following organizational units can SCPs be applied? In other words, 3 of these things belong to IAM. They don't belong to organizations. Which 3 things here belong to IAM, and then pick the other 2. So we know an organizational unit can have an SCP applied to it. And then Nathaniel, I see that you said, hey, a member account could also have a control policy applied to it. All accurate. Good, Sabrina and Nathaniel, that's good. Okay. So that was organizations, which is about how to manage multiple accounts inside of AWS. Let's talk about this last one, because this one kind of cracks me up a little bit. I feel like often like this is like some kind of like weird flex by Amazon where they're like, hey, look at my muscles. It's like, the artifact service inside of Amazon. So just so if you've never seen this, this exists inside of every AWS account. So artifact is where you go. Not code artifact, although that's funny. I forgot about code artifact. Artifact is where you go when you want to see any agreements that you've made or that Amazon's made with government entities, or if you want to see things like any reports, like compliance reports. Let's say that you were really interested in 27001 ISO reports. Guess what? You can find all of them right here. So you can actually download their reports, right? If you want to, and see what's happening inside your account. Sorry, what's happening with AWS around their compliances and security certifications. So this is Artifact, which kind of cracks me up because really what they want you to know is that they have a tremendous number of security certifications. Now, you probably already are aware of this because Booz wouldn't even be using them if they didn't have a high level of security certifications. But they've got FedRAMP, they've got all kinds of stuff here. HIPAA, PCI, PCIDS, I mean, 27001, 27017, they've got them all the world over. Now, just because something, by the way, just because Amazon has HIPAA compliance doesn't mean that every single service is HIPAA compliant. So devil's in the details. So make sure you read the details. There's also a customer compliance center. How do you find it? It's really hard. You just go onto Google and type in AWS Customer Compliance Center. It'll be the first thing that comes up. It's usually Amazon.com, aws.amazon.com/compliance. Here's the center, and you can find all kinds of white papers and documentation, including code of conduct, auditing checklists, more like tons of white papers, like stuff that, you know, it goes deep. Workbooks. Okay. So just a reminder that Artifact allows you to view their certifications and attestations. It also allows you to complete agreements inside of for AWS. So if you sign an enterprise contract, it'll show up there as well. All right. Knowledge check. Wow, I just said this actually. Which task can you complete in AWS Artifact? You can access compliance reports on demand. That's correct. You can also review, accept, and manage agreements with AWS. That is also correct. Good. All right, last few things here. What if you need, from a security perspective, to either monitor or defend your applications beyond the firewalls that we looked at earlier? What if you need a filtering firewall, like that will do like layer 7 filtering, like that will filter like for websites and stuff? And what if you are constantly getting attacked by a distributed denial of service attack? What do you do then? Well, Amazon's got answers, and they have so many security tools. It's a little weird, and they're putting more up every day. I'd be shocked. Reminder that reInvent is happening this week. This is when Amazon usually announces all their new services, which are typically in beta. My words, right? So you might want to wait a second before you start messing with them. But one of the first lines of defense that you can put up is that you can actually filter legitimate traffic from illegitimate traffic. Like you can put a firewall in front of your application to make sure that the only thing coming in is good stuff, not bad stuff. The other thing to note is that in addition to filtering with a web application firewall, you can also block people who are trying to knock you offline by using something that comes for free with AWS called Shield, and it's always active by default. If you need more protection, though, from a distributed denial of service attack, then know that you can also use what's called Shield Advanced. And so Shield Advanced in particular integrates with other services, but what it does is it, in a sophisticated way, it stops you from getting attacked and knocked offline. It also offers pricing mitigation if you happen to be paying top dollar to stay up in the middle of an attack. So just know that WAF and Shield are two tools that can work together to really protect your application. Other thing to note is that Amazon Inspector is a vulnerability assessment tool that works both inside the operating system and across the network outside an operating system to assess whether your system has known vulnerabilities in it. So to tell you, for example, if your web server is running a piece of software that's unpatched, it'll actually let you know that something's happening. So WAF, Shield, and Inspector. WAF filters layer 7 traffic for malicious intent. AWS Shield and Shield Advanced will actually block distributed denial of service attacks. And Inspector is literally used to inspect your EC2 virtual machines for vulnerabilities, both inside and out. Here's some additional security services to just be aware of. One, if you want to encrypt your hard drives or your data, then you're going to end up using the key management service. When you actually flip on EBS encryption, the hard drives, if you actually turn on encryption for an EBS hard drive, it actually uses the key management service to encrypt those hard drives using symmetric and in some cases asymmetric keys. There's also guard duty. So the key management system is used for encryption. Guard duty actually uses machine learning to watch your network logs, your DNS logs, and some other logs. CloudTrail is what the other logs are. And it basically is watching for malicious intent against your network. So it sees who's probing and where it came from and identifies attacks proactively before they happen. By the way, if it sees something happening, it's not going to take action. It's going to send you a notification, say, hey, I got weird traffic coming from, Peru, like pick a country. Do you want to do something about it? Or should we just let you know? All right, some knowledge checks. So what is an actual IAM policy? Someone pick a letter that says this is what an IAM policy is. That's right. It's a document that grants or denies permissions to AWS services and resources. Good. Okay. Sorry, I clicked through that a little too fast. An employee requires temporary access to create several Amazon S3 buckets. Which option should be used for this task? If someone needs temporary access out of the 3 possibilities, either an IAM role, a group, or a user, which of those 3 did I say was specific to temporary? Role. Looks like people got it. Good. Remember, roles are assumed and then they're relinquished. So like even over here, where you can see that I was signed in the console, once I'm done doing my work, I'm going to go back to Spartan Sage and it's going to step me down to being Spartan Sage. So I'm going to let go. Okay. All right, so we already answered role, so we're good there. Which option describes the concept of least privilege? So if I want to set up a user and I want to follow the concept of least privilege, which of these matches that? Good, yeah, granting a user only permissions that are needed to perform that specific task. Which of these services, by the way, is part of the application suite that protects against distributed denial of service attacks? There's a basic version and an advanced version. Good. Shield or in Shield Advanced, right? Okay. Which task can the KMS service perform? The AWS KMS service. I didn't really call this out explicitly. I said it could generate these, but I didn't say, I didn't use the exact wording they use. I said symmetric or asymmetric keys, which are all forms of basically C, cryptographic keys. So well done. Okay, so in this module, we learned about the shared responsibility model. Remember, security of the cloud, AWS, security in the cloud, us, right? A little bit about IAM, including the users, the groups, the roles, and the policies that get attached to those. We talked about organizations with SCPs and organizational units and how you can use those to block access to certain services and consolidate billing. I also talked about WAF, Shield, and not trusted advisor. WAF, Shield, and Inspector has ways that you can protect your applications and your EC2 instances. We talked about AWS Artifact and all of its kind of compliance glory and how you can actually put agreements and track compliances inside of AWS at that location. Questions or comments of any type? Okay, so before we get into monitoring, let's take a 10-minute break. So it's 2:07 right now. Let's take 10 minutes and come back at 2:17, probably like 2:18 because it's almost 2:08. Okay. We'll come back with any questions. Otherwise, step away from your computer. A little post-lunch stimulant. We'll see you in a bit. Okay. Any questions about the path we've covered thus far? We've actually covered quite a bit in this time frame. No? Okay. Well, let's talk then about monitoring and analytics as our next stop. So what we're going to do here is we're going to have a conversation basically about how to monitor things. And it really revolves around quite a few services. It's really, there's really 3 services, and I know it lists a different one here, but it's really CloudWatch, CloudTrail, AWS Config, which might as well be called AWS Config Tracker because it doesn't actually configure anything. It just tracks configuration changes. And then Trusted Advisor, which I always laugh that they put Trusted Advisor in here because it's really only available to enterprise customers, of which obviously Booz is clearly an enterprise customer. But you have to have a support plan for it to really be of value. So let's talk about it. So CloudWatch is the first service because, well, CloudWatch is metrics. Don't get me wrong, CloudWatch has, let's see, I want to say 11 sub-services underneath it, all of which are all about metrics or logs. It's really just about insights, dashboards around logs, insights around logs, container insights around performance. It's really, CloudWatch is really about watching performance. Now, let's say that you had metrics in terms of like, you want to know the average wait time of a, customer per hour or the remaining number of pastries. And you had thresholds like SLAs or SLOs where if these get crossed, you want a response. Like I want to add another barista, or I need to open up another cash register, or I need to order another set of pastries. This is what CloudWatch is really for. CloudWatch has a bunch of different components, but CloudWatch basically takes numbers, allows you to configure alarms to those numbers, and you can even trigger responses using CloudWatch events based on those numbers. Now, it also allows you to present data in a very pretty way, but just be aware that CloudWatch is all about the metrics. How are your services performing? How are your EC2 instances performing? And if you put logs in there, it'll include logs as well. CloudWatch is the metrics repository. That's its function. Now, in addition to having a metrics repository called CloudWatch, Amazon has a tool called CloudTrail, and CloudTrail's job is to log every call made against your Amazon account. Not the actual running of the services inside your account, but if someone comes in and tries to do something to your account, like start a service or delete a service, CloudTrail's job is to track all API calls made against your account. So whereas CloudWatch watches the performance of services, CloudTrail simply is going to capture everything that was done either today, 2 days ago, or 3 days ago. Right? So really CloudTrail is used for forensics. How do I know when something's gone? How do I know when something's gone wrong? And how do I understand why it's gone wrong? Like, why did it go wrong? Right? So CloudTrail basically tracks all API calls. And what happened is it will tell you what happened, who did it, when did it happen, and like how did they make the request? Did they do it through the console, through the command line, or through an SDK? So CloudWatch tracks the performance of all services. CloudTrail tracks who is doing what against your AWS account. And the last service that they recommend from a monitoring analytics standpoint is Cloud Trusted Advisor, which we'll get to in a second. But first question, which task can you perform using CloudTrail? Which two? Good. Yeah. So everything involving metrics or monitoring is going to be CloudWatch, which is not what the question is asking. They're asking about CloudTrail, right? So tracking user activities and API requests, that's definitely going to be CloudTrail. Filtering logs to assist with operational analysis and troubleshooting. That could be generic, like it could be CloudWatch or CloudTrail, but most of the time it's going to be CloudTrail. Okay. All right. On to Trusted Advisor. Okay. So imagine if you were like, hey, can someone just automatically watch our coffee shop and tell us if things are going awry? But be nice about it, right? Like, hey, you ran out of pastries, or you're about to run out of pastries. Is that what you want? Hey, you just overcharged that person for coffee. Did you mean to do that? This is what Trusted Advisor does. Trusted Advisor exists inside of your account. And what it does is it gives you guidance on what's going on inside your account in a central location. It looks like this, but let me show you what it looks like inside of a real console. Now, here's the cool thing about this is that I do not actually have a support plan for my demo account, but you still get a pretty good idea of what Trusted Advisor is going to do, right? Notice that I have 0 recommended items, but I have one kind of a investigation. It's under security. It basically is saying, hey, one of your security groups is completely unrestricted. You should fix that. But notice there's all these other checks that I don't have access to. If I go straight to the dashboard, it's just going to show me this. So that the view that you just saw here is the old dashboard. Here's the new one, right? Notice I don't have any excluded items. I have no like high quality items. I just have like a warning. Hey, one of your things. Now I can upgrade my support plan if I want to get access to more checks, but just know that your support plan is a percentage of your total spend or a minimum amount. So like, just to show this, I could probably get the developer one at $30 a month, but to say this is that I already have access to 7 core checks from basic, so it's not going to give me any more. But if you sign up for business or enterprise, which just to say this is either $100 per month plus a percentage of spend, or it's $15,000 a month, or a larger percentage of spend. So just know that trusted advisor, requires someone to have an enterprise support contract for it to function. Okay. But trusted advisor will warn you if you hit service limits. It'll warn you if you have security violations. It'll warn you if you have unused resources, and it'll send you an email and say, hey, by the way, someone just opened up an S3 bucket to the world. Is that what you wanted? Kind of nice. All right, quick knowledge check. This one, I told you it's going to be a short one. What actions can you perform using CloudWatch? Let's pick two. A and D. Monitor your resource usage and performance, and then access metrics from a single dashboard. That is correct. Remember, receiving real-time guidance for improving your AWS environment. That's going to be trusted advisor for the most part. Compare your infrastructure to best practices in 5 categories. That's going to be trusted advisor. Automatically detect unusual account activity. Well, I don't even know which one that will be, actually. Automatically detect unusual account activity. CloudTrail would be that. GuardDuty does VPCs. I guess between the two, you could get covered. Regardless, A and D are definitely the right answer. Which service can you use to review the security of your S3 buckets for open access permissions? Oddly enough, I think I just said that a little while ago. Good. I see trusted advisor there. Perfect. Which categories are included in the trusted advisor dashboard? Ooh, this is a good one. Interesting that they would ask this, right? This is like a straight up memorization thing. I give you a little bit of help. Elasticity is definitely not included. Neither is scalability. So out of the 3 remaining, which of the 2 do you think are on the dashboard? Yeah, good. Other ones would be cost optimization, performance, fault tolerance, security, and service quotas would be the other one. Good. Good. That was a short little module that just talked about CloudWatch, CloudTrail, and Trusted Advisor. Don't forget about AWS config. And as far as like monitoring services for both your account and for your services, between config, CloudTrail, and CloudWatch, you pretty much have everything covered. If you're looking for stronger security services, well, there's a whole list of those. Everything from Macy, which does like PII scanning and stuff like that. But as far as like monitoring and analytics for your systems and account, these are the ones that they're the best. Okay. Questions of any type. So Sabrina, what config does is config tracks when there's a state change inside your system. For example, it will instantly notify you if somebody like pops open a security group inside of like a firewall. And what's interesting about config, unlike trusted advisor, is that config can trigger a response. So let's say someone opens up a firewall on your system and opens it up to the world, and you're like, we don't allow that. Config can trigger CloudWatch events, which can trigger a Lambda function, which will then shut the firewall down. So config is used when you want to respond in real time, not when you just want to alert in real time. So config actually tracks all the state changes. So oddly enough, Trusted Advisor uses config to gather information, but you can actually use config to gather any changes of state in your environment and like hijack an immediate response. So it's good when you want to have like not just enforcement, but remediation of policy violations. Yeah. remind me when we get to here, amazon.quicklabs.com, because there is an AWS config lab here that you will all have access to when we talk about this later. So you can actually dive into monitoring security groups. You can actually do what I just talked about. Okay. Now we're going to talk about pricing and support, and this is going to be one of the weirdest conversations we have all day. Why? Because man, we really cannot peel back pricing and support because every single service has their own unique dimensions of pricing. What I can talk to you about though is how to figure out how Amazon's going to charge you. Okay. So this one always weirds me out a little bit just because I feel like it's a bigger topic. So what we're going to do is we're going to talk a little bit about the pricing and support models just in general. And I'm going to show you how to figure out how something is going to charge you in AWS. And then we're going to describe the AWS free tier. And so basically the free tier is that you can create an account in AWS and you have access to some free services, but don't be fooled. There's no enforceable limits. Amazon will let you go beyond the free tier. And don't get me wrong, as long as you don't leave anything running, you're not going to spend hundreds of dollars or tens, whatever. But some things are free in Amazon, some aren't. We're going to talk about what those are. Talk a little bit more about organizations and consolidated billing, and we're going to talk about all the various like tool possibilities inside of AWS. So we're going to talk about a little bit about budgets and Cost Explorer and the pricing calculators and the support plans and marketplace and stuff like that. All basically around either getting support or getting access to third-party services. So let's dive into it. First of all, this is the answer to these two questions is one, how can I budget and pay for AWS services? And two, how can I find support for AWS and third-party software that will work well in the Amazon ecosystem? All right, first thing, free tier. So let's go back to Mozilla for this. AWS free tier. All right, so when you create an account on Amazon for the first 12 months that you have that account, you get a bunch of services for free, but only some of them are free for the first, only some of them are free forever. A bunch of them are free for the first 12 months. So let's look at this. So the first 12 months are free for, you can run a basically T2 or T3 micro, either Linux RHEL or SUSE Enterprise Linux server for months. Like you can run it for 12 months for free. You can also, by the way, store 5 gigabytes of S3 storage. You can actually run your own database server, right? You can run an API gateway. These are the ones that are only free for the first 12 months. After this time, the only ones that are always free are DynamoDB, Lambda, SNS. In other words, the high level services are always free. After this, it's not free anymore. By the way, Chime is Amazon's GoToMeeting. Oh my God, it's horrible. At least it was a year ago. Maybe it's changed, but it was pretty bad. Macy, SES. Notice there's a bunch of services here. SQS is here, database migration service, code pipeline, code commit, blah, 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 blah. So just know that key management service, step functions, there's a bunch of stuff here that is free forever. And there's a bunch of stuff here that's only free in the next 12 months. There's actually 4 pages of this stuff. Transcoder, GameLift, Lex. Anyway, bottom line is that if you want to see what's free and what's not, is that you're probably going to end up coming out here to the free tier and doing it yourself. Oh, you want to remove that question mark. Sorry, that was an accident. Now you might say, well, Michael, why do I care? Well, because I do actually recommend that all of you create a free account. Please do not use your bah.com email address to create an AWS account. You're going to get a call from security if you do that. It's not going to be ugly. They're just going to ask you what you did it for and can you delete it, or they'll delete it, right? So just be aware. So just know that some of it's free, some of it's only 12 months free. Amazon gets a lot of flack for this because people want them to put limiters on their account, so where you can't start resources that aren't included in the free tier. I think they're working on it. We'll see. That, you know, it kind of blew up in the Twitter space there for a while. There are trials, by the way. They do give 90-day trials. This is very service specific. So when they offer a new service, they'll usually give you like a 30-day free trial or something like that. Yeah, just be careful, right? Don't start something that then expires and then rolls into pricing. And next thing you know, you spent, you know, $200 in a month on something. Just shut things off when you're not using them. That's the bottom line. If it's just you, right? Okay. Now, beyond the free tier, here's the cool thing. Just know that you pay for what you ask for and what you use. So if you run an RDS instance for a week, you're only going to pay for a week. You're not going to pay for a month. You pay less when you like use a reservation. So, you know, please use a reservation when it makes sense. You also pay less when you with volume-based discounts. So just know that, you know, as you use more and more, the price per unit decreases, right? Which is, we love that. That's what we want. Other things to note is that if you really need to know the dimensions of pricing, there's two places that I recommend you go look. Because you're like, I really want to understand how pricing works, Michael. Well, you're not going to. What you need to do, though, is how to find it. So there's two places. One is the simple monthly calculator that you saw me go to earlier, right? That's this little link that I'm about to share with you. The other is calculator.aws. Calculator.aws is Amazon's newer site for services, but it doesn't have feature parity yet, which is why some people still use the old site and why people have been clamoring for AWS to keep it. So let's say that you're like, I would like to, and I'm going to disable free tier for a second. Let's say I want to find out the cost of something. Let's say it's RDS. And I want to run a Aurora database, and I want to do the MySQL compatible version, and I want to run the smallest one possible, which would be like a T2 medium. And I want to use 20 gigabytes of storage, and I just want to see how that's going to go. And I'm going to probably do, let's say, 1,000 requests a month. This is going to cost you $62 a month to run. Right now, I don't have free tier enabled. I wonder what happens if I enabled free tier. Hey, it goes down a little bit. I wonder if I can do a T2 micro. Hold on. Oh, they don't have a T2 micro. Not for Aurora. Well done, Amazon. Which if I switch this to MySQL, it'll run. Oh no, it's still not there. Oh, there it is. T3 micro. There we go. By the way, if I run a T3 micro and I do a standard MySQL, it's going to go down to 1245. So I guess my point in all this is that, you know, this is how you figure out the dimensions of pricing. It's going to ask you questions like which licensing engine, which size of system, how much storage, what kind of storage do you want? Are you using provisioned IOPS? If you're like, Michael, I don't really know. Or let's say you're just using S3, for example. And you're set like, it's like, how much is it going to cost you? Well, let's say you want to store a petabyte of information up on S3. A petabyte, by the way, is going to run you about $25,000 rounded up. Let's say you're going to do, let's say 1 million requests where you're basically going to 1 million copies of files per month. And you're going to do 10 times the number of reads, right? Notice that the price hasn't changed because that's actually an infinitesimal number of reads and writes against a large data set, right? But my point to this is that you don't need to know the details and memorize all this stuff around S3. You can just come out here and look and find out what questions you need to technically ask your team or have them look and figure out, okay, how big are the files you're sticking on S3? What are the number of reads? What are the number of changes? Are you using anything special like S3 Select? You're not? Awesome. Then this will teach them the dimensions of pricing. Same with calculator.aws, which is the other pricing site. The cool thing about this one is that you can create an estimate and you can create multiple estimates for projects. So this one I think is better for projects compared to the older one, because you can actually create and save and share estimates with other people. So for example, here, let's say you were going to add S3 to an estimate. You could turn on S3 standard. Let's say we were going to do, you know, again, 1 petabyte per month, except this time we're going to do 1,000 because, right? And oops, I did not mean to do that. Let's say we're going to put 1 million in, and we're going to do 1 million reads. Sorry, 10 million reads. We're not going to use S3 select. It will actually show you all the calculations it did. And then it will give you the estimate. Now notice this estimate is lower. Why is this estimate lower? Did I do something different here? Maybe it's because they translate this differently. Let's do 1024 and see what they say. Oh, something's different. Huh. And they're going to ask you a data transfer question. So maybe this one's more accurate. Maybe there's something wrong with the other one. Anyway, it's going to give you a ballpark, right? Although that's $2,000 off, which is like 10%. So that kind of throws me a little bit, honestly. I'd be very interested to know what the discrepancies are here. Regardless, I can then take this and add this to my estimate, and I could add multiple services to my estimate, and then calculator.aws would actually have all of my project services listed as an estimate, and I could see and dig in and see exactly what math was done to calculate that number. So if you need to do forecasting on estimates, the simple monthly calculator is going to be great. You can also talk to your AWS partner if you have one, right? So just know that between calculator.aws and the simple monthly calculator, you can actually get the dimensions of pricing for almost any product. Let's say that we wanted to add another service and we were really excited about Redshift. Remember, Redshift is a data warehousing service. So let's say we came out here, we're going to run it in Virginia. We're not going to change it. And we want 1 node, but we want to use the new DC3s. Can I use DC3s? Yeah, I think I can. Sorry, the RA3s. We're going to use the RA3s because I need 84 gigs of memory and I need 48 CPUs, right? But I'm going to reserve these because it's going to run for a year, and I'm going to do a partial, sorry, no upfront. I'm going to run it for 3 years, actually. I'm not going to add anything else to it. I'm just going to add this to my estimate, and guess what? Now Redshift shows up as $4,000 a month, no upfront, right? And so now I'm spending about $27,000 a year for S3 and for Redshift. So again, these tools will teach you what the dimensions of pricing are. So you have to go like blaze through the documentation to find it. You can just see it right then and there. Does that make sense to everybody? There's not going to be a big expose on the pricing of like Lambda and whatever, because you actually need to come and take all these services out on an individual basis and figure out what their charging is. Okay. All right, so we talked about the pricing calculator. Let's see. All right, we talked about S3 pricing. Ah, there was one thing I wanted to show you. That's right, because it's in the list. Let's go back to our login. In any account that you're logged into, typically if you're logged into the AWS console, there's a billing dashboard that you can click on that will tell you what you're spending, right? And so notice that right now, the forecast for November is that I'm going to spend 36 cents. Now you may say, Michael, you really haven't spent anything. That's kind of true. I get free credits. So I'm an Amazon authorized instructor. So I get free credits from them to do stuff in my demo account. It's not a whole lot, but like I usually don't break it. I usually go above it, right? But if I want to see the details on what I actually spent, what I can do is, let's say, for example, config, which I was just talking to somebody about in North Virginia. What did I actually spend? Now you can see that it looks like I spent 55 cents and Amazon gave me a credit, right? They gave me a credit and knocked it and reduced it back down to 0, 55 cents, right? Big deal. Let's say data transfer wise, they gave me $1.15 credit. But my point of this is that this is November's bill. See how it says November up here? I can go all the way back if I want to, back to when I first created the account God, was it really just June 2016? Thought it was newer than that. Interesting. Regardless, this shows all of my billing history for this particular account. I probably have another account that's older, right? So if I go back to August, right, to see my usage then, let's see how many total credits I had. Looks like $34 worth of credits. That's it. That's all I spent in my demo account. Because it was either free tier or, right? So I find that fascinating. So simple storage service, simple queuing service, simple notification service, secrets manager, Route 53. This in detail shows all of the services that I use. This is just the billing detail. Now notice on the left-hand side, there's other things like, for example, Cost Explorer. If I go and launch Cost Explorer as an example, this will actually take me into a whole nother service, and it's going to show all of my costs. Notice it says that CloudTrail has gone up a little bit. Key management service costs have gone up a little bit, right? So it's showing that like things are going up. Because actually I started using Oregon as well, right? Now, notice it says 91% down over last month, right? So this will, by the way, will allow me to see reservations, savings plans. It'll actually do cost anomaly detection. So if it sees a huge deviation in cost, it'll immediately send me a notification and say, hey, by the way, you went up to $2. You usually spend $1 a month here. What's happening? Which is kind of nice. So savings plans, reservations. Other things to note is that I actually have budgets set on my account. So for example, if I go over $12 off of anything over containers, it's going to send me a notification. I have like networking set to $10. I don't think I've gotten an email in a second, actually. Let's see. What do these numbers say? 65 cents, $1.12. Yeah, no wonder I haven't gotten any emails. Not really spending anything, right? You can see any savings plans that you might have, right? You can actually see any budget reports. You also can download to the millionth of a penny all of your costs and usage reports. You can download them as a spreadsheet and compile and do your own math on them. It's actually pretty cool. If you got any credits, those will show up here. So notice I have some credits here. If you have any payments where I've like made payments against this account, I don't know that I've made payments in a long time. Yeah. And of course, bills we were looking at earlier, so you can see all your bills, right? Now, here's the cool thing about working for Booz. Most of the time, you're not going to see this, but just know that if you're helping with someone else's account, you're probably going to get in the middle of this a little bit, right? Remember, I said there were two things that were harder inside of AWS. That's security, not because security is hard, but because our mindset around security is different for cloud. But billing is also harder. So just know that this is a deep rabbit hole you can really get sucked into. General rule of thumb, if you want to forecast, you have to have historical usage. In other words, Cost Explorer will tell you what it thinks you're going to spend, but it will only do that if you actually have a history in here. If you don't have any history, it doesn't know what to tell you to spend. So if you have a brand new project, you have to use the simple monthly calculator to guess spend. You can't actually use it based on, right, past reports, past history. So if you want to forecast and it's a brand new project, you have to use either the simple monthly calculator or calculator.aws. If you want to forecast what you're spending against an existing account with existing usage, Cost Explorer can help you. If you just want to put limits and get notifications when you cross a certain weekly budget, that's what budgets is for. And if you need detailed to the millionth of a penny, you can use the cost and usage report to get information. Okay. So that's the billing dashboard, which has got all this stuff inside of it, right? That we just talked about. Okay. Here's a test. The AWS free tier includes offers that are available to new AWS customers for a certain period of time. What is the certain period of time that you get for free with a new account? That's right. So 12 months, right, is the duration. So free for 12 months. Good. All right, so let's talk a little bit then about consolidated billing. Okay. So consolidated billing is about taking all of your accounts and consolidating them into one view. You may have noticed over here that when we were messing around with my account, that I actually do have some linked accounts in here. So notice I have 3 other accounts in here that are linked, right? Interesting. Where are the rest of my accounts? Well, let's go take a look at organizations really quick. So organizations is that program that we talked about, that the service that basically allows you to aggregate a bunch of accounts together. Now notice I've got a management account, I've got UAT, I've got a student account. These are all accounts underneath my management account right here. The billing for these all folds up into AWS. Now, I don't think I've started anything in either of these accounts, but if I did, they would show up under that linked view that we were just looking at. But since I don't think I've run anything under these accounts yet, since I just like created this back in October, not the demo account, but just the organizations piece, there's nothing showing up, right? So if I go and looked at this by linked account, the reason it's not showing me anything else is because, well, there's nothing else to show because nothing's been charged. Only these 3 accounts have incurred charges over the last 6 months. If we get a little detailed and say, look, what if I just want the last like 7 days? Notice there's nothing here because everything keeps getting credited out to 0, right? So there's no real like usage here. If I look over the last, let's say, year, notice that it looks like I spent, like bought a domain name, maybe bought some services back in November 2020, December, April 2021. Right, looks like I spent some money then, but that's it. Otherwise, $24. Everything else has been zeroed out or credited out for some reason because I have credits on my account. So what this means is that consolidated billing allows me to take a bunch of accounts and consolidate everything into a single management account. Now, remember, this also is where I get volume discounts as a result because I got account 1, I got account 2, I got account 3, and now I've got the management account, and all 4 of them together, the consolidated bill is brought together to $73.80. If this was S3 spend, what would happen is that, look at this, I've got now 14 terabytes of total S3 usage. Because I've now crossed the 10 terabyte threshold, what that means is that now 4 of those terabytes are going to be cheaper than the previous 10 because now I'm getting volume discounts by aggregating all my stuff together. So consolidated billing not only gives you discounts from a reservations perspective, but when you aggregate all your usage together and your total spend gets higher, they start discounting you on the spend. Again, not a huge fan because I think to spend more to save more is kind of a bad intention. But if you're already spending it and you want to save some money, then this is great, right? So just know consolidated billing gives you volume pricing as well as consolidated discounts. All right. We touched on this a little bit already because you saw budgeting inside of my demo account. But note that you can set budgets, you can set thresholds, but they're only going to be notification thresholds. Amazon has been rolling around some hard thresholds to stop you from launching resources. Really haven't seen that come to fruition yet. Next is Cost Explorer. So notice that for Cost Explorer, it's a tool that you can use to visualize, understand, and manage cost over time. What did I say was the caveat if you're going to use Cost Explorer to do forecasting? What do you need inside Cost Explorer if you want Cost Explorer to forecast your spend? Michael, that was perfectly stated. Matthew as well. You need historical data. No historical data, no forecasting. If it's a new project, what are you going to use instead of Cost Explorer? New project, you're going to do costing. What are you going to use instead? Yeah. use the simple monthly calculator or use calculator.aws. Both are valid answers. It just depends on what you really like. Just know that they are going to actually get rid of simple monthly calculator eventually. You know, they're going to have to. It's getting a little long in the tooth, and obviously there seems to be a cost discrepancy there. That kind of weirded me out a little bit. I'm going to figure that out. Okay. So just remember, and by the way, that does show up on the exam. They'll try to trick you. They'll say, hey, you've got a new project, and what tool do you use in order to forecast usage? And it'll say, pick two. And it'll be like, Cost Explorer, budgets, calculator.aws and your Amazon partner. And the answer is calculator.aws and your Amazon partner. Which I'm like, why would I talk to my Amazon rep for that? But you will, actually. If you had access to them, you would talk to them about that. I have had access to them in the past. Usually at large enterprises, you don't have direct access to your AWS partner. Okay. All right, last but not least, I got to talk about support plans. Why? I mean, come on. This is Cloud Practitioner. We're gonna know what the options are, right? So first of all, just know that you get free support through support cases, but you don't get access to anybody. You don't even really get email support. You don't get chat support. You basically just get basic access to technical papers, documentation. You can also contact support for quota limit increases, but they're not really going to support you for anything. I know. You're on your own. And then there's Bazinga, the 3 support plans, which you saw on the demo site earlier that I was looking at. It's like $29 a month or your percentage of your spend. It's $100 a month and an even larger percentage of your spend, or it's $15,000 a month plus an even larger percentage of your spend. So just know that like the business and enterprise plans are serious. I've actually had an enterprise plan, and I got to tell you, it was a great value. You get a technical account manager, totally dedicated, awesome, worth doing. And they respond within like 15 minutes. Plus you get to talk to the product teams. You get to do all kinds of stuff. I'm pretty sure, by the way, that Boots is a enterprise support plan. By the way, which of these 2 are going to grant you access to the full set of trusted advisor checks? This is on the exam, by the way. Good. Yeah. Also, I'm just going to apologize to you. You do actually have to go in and kind of quasi memorize the response times for business and enterprise for Cloud Practitioner. I mean, maybe I'll apologize. I'm not the one doing it. So just know that like you need to know that enterprise will give you 15 minutes of critical systems down and an hour of production response time. So they'll respond within an hour or 15 minutes if it's a business critical system. With the business support plan, they're going to give you, it's going to take them an hour to respond to a production issue. So you now know. Just know that enterprise support, you do get a TAM. It's a single point of contact. They work in addition to your partner. They provide a full range of AWS services. Yeah, they're basically your partner. They're going to be the first on the call and usually the last to leave when you have an outage, typically. Okay. Which of the following is the lowest cost AWS support plan that includes all of the trusted advisor checks? Hopefully I emphasize that enough. Good. Yeah, business A. Good. I see that I did say it enough. Perfect. Good. Okay. All right, here's the last thing that we're going to talk about. Well, for this module is the marketplace. So the marketplace is a digital catalog that provides a listing of third-party software that runs on AWS. How do you find it? Well, let's go take a look. Dun, 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 dun. Oh, now they're calling it digital marketplace subscriptions. That's weird. Okay, we'll just roll with it. think I have any subscriptions. Let's discover some products. Okay. Let's say you're like, you know what? I really love Kubernetes, but you can't spell it because you just saw me start it with a KI. Right? I can get Kong for Kubernetes Enterprise. There's a Kong Kubernetes Sandbox. Here's the Red Hat OpenShift service, by the way. Right? CentOS Guacamole Bastion hosts. Nice. Calico, which is by Tycera, which is actually kind of a network security policy that you can deploy inside of Kubernetes. Ooh, Kubernetes consulting, nice. Anyway, my point being is that you're like, man, I just really love Cisco devices. Well, you can find the ASAVs, right? The virtual versions, the VMXs, the Meraki's, all that stuff. Let's say you really love Fortinet. Does Fortinet we still love Fortinet? Anyway, here's FortiGate. Let's say you love Blue Coat. Is Blue Coat still around? I haven't heard their name in a while. Maybe they got bought by somebody else. That's another one. I wonder if Checkpoint's still around. Yep, here we go. In other words, if you're looking for third-party software, you can typically find it out here. Someone the other day was asking me about TIBCO, which I think is one of the oldest and largest, like kind of like analytics buses systems that I've seen, kind of like SAP. Yeah. Oh, cool, Michael. Good to know. Anyway, guess what? My point in this is that if you're looking for software, you can find it out here. So, obviously you're not going to find everything, but like, I don't know, almost everything I've ever looked for has been out here in some form or fashion. Oh, I know what I was looking for the other day. I was looking for Solaris. I was like, are people still running Solaris? You know what? They are actually, and they're still running Spark as well, which just cracks me up. So anyway, that's what the marketplace really is it's a place basically to find software. So if you're looking for software from a vendor, it's probably going to be out here. And by the way, that includes networking appliances, IoT devices. It doesn't have to be stuff that Amazon supports. The vendor will support it. Here's one little catch. If you launch one of these, you're not only going to pay for the EC2 cost, but sometimes you pay a subscription as well. It's going to show up on your Amazon bill. Just be aware of that. So, okay, here's a bigger knowledge check. Sorry. What action can a customer perform with consolidated billing? Good. Combine uses across accounts to receive volume pricing discounts. That is correct. Excellent. Well done. Okay. Which pricing tool is used to visualize and understand and manage AWS cost and usage over time? So both past, present, and future. Excellent. Good. I'm glad that stuck. Which pricing tool can a customer use to receive alerts? Oh, sorry. You know, I kind of glossed over that because you were all typing the right answer. It was Cost Explorer. Just want to make sure I confirm that. Which pricing tool can a customer use to receive alerts when their service usage exceeds a customer-defined threshold? You actually saw mine set up. Good. Budget is correct. Okay. A company wants to receive support from a TAM. They want a TAM. What do they put in? Which support plan should they use to get a TAM? You want big support? You got to pay big money. That means the enterprise is the way to go. Okay. Last but probably not least, which service or resources used to find third-party software that runs on AWS? You can give both the name that's here and the special name that we just saw was added. Good. Yeah, marketplace or marketplace subscriptions, which is the first time I've ever seen it say that. Cool. All right. We just went through a bunch of stuff, including free tier, consolidated billing, tools for, planning, estimating, forecasting, all that. We talked briefly about the support plans, and then we talked about that the marketplace exists and you can get third-party software from it. Okay. While I'm transitioning, please ask questions. Perfect. All right, let's take a look at that, Ian. Let's take a look at this, the enterprise support plans, AWS. Let's take a quick look. Let's compare the AWS support plans. Okay, so this is a kind of a bigger version of what we saw before. Here's the part that gets like this shows up. See this? Don't worry about memorizing general guidance. Don't worry about system impaired. Don't even worry about production system impaired. Production system down, it's an hour for both systems. Oh, hold on. Let's pause for a second. I just want you to note something here. They added a new one. Do you see this? I just noticed this. I've never seen this before. They just added an enterprise on-ramp section. So this is a brand new support plan. Ooh, but it's not going to be on the test, by the way. Not yet. All right, so ignore this other one. This is the one we want to pay attention to. So production system down is going to take an hour on business plan. It's also going to take an hour on enterprise, but with enterprise, you can actually designate some systems as being mission critical, and they will respond in 15 minutes. Ignore, by the way, the enterprise on-ramp because that's brand new. It's not going to be on the exam. But notice the only difference there, by the way, is they've added a 30-minute business critical, right, system time. Interesting. Does that mean it gets all the trusted advisor checks? I wondered why it said there was 3. That's interesting. So I'm going to post that in chat, so you can have access to it. Support API. Oh, look at this. Access support automation workflows, no deep dives. Oh, a pool of TAMs versus a dedicated TAM. Oh, that's nice. By the way, you do actually get training included when you buy an enterprise support package. So training is included for free. Oh, look at these changes. So $100 a month, that's good. But $5,500 or 10% of monthly usage or $15,000 plus, oh my gosh. Yeah, there's a lot there. Okay. We are on the last 2 sections. So I'm thinking we should take a break. Is everyone down with a break? Are we okay with taking just a short break? Yeah, let's take a short break. All right. So it's 3:09. Let's take a 15-minute break. So come back at 3:25. So that's 16 minutes technically. I'll put a timer up. So let's take a short break. That's okay, Michael. I wasn't offended. You could scream yes all you want to. All right. So 15-minute break. We'll come back at 3:25. We'll see you in a bit. Let's get to it. Okay. I feel like I should tell a story. Once upon a time, there was a cloud company. No, there was a book company, right? No. So we're going to talk about migration and innovation. We're going to summarize, which they just released version 3 of the cloud adoption framework. 6 factors or ways of thinking about migrating to cloud, of which 2 aren't really relevant because they're actually about retiring. And then benefits of data migration. And then we're gonna like sing AWS's praises for just a second. And then there are 5 pillars to the well-architected framework. I didn't realize that we summarized them. I just taught this like last week and I don't remember doing that, but maybe we will this time. The well-architected framework, by the way, is a filtering framework that allows you to look at your architectures and make sure that you're building them for like, cloud native applications really. So let's talk about it. So the first is the CAF, first the cloud adoption framework. So this one basically is ways of thinking about like governance and people and security and just like in both business and technical capabilities to kind of act as a helper for how you adopt cloud, both from a business standpoint and a technical standpoint. It has these general categories in it as far as like, you know, what's relevant for the business, what's relevant for governance, people, et cetera. It includes the basic, like, you know, infrastructure pieces around platform security and operations perspectives for technical capabilities. So it talks about like what the goals are, what the common roles are. It does this for people as well. Like who should be involved, what should they be creating and crafting, how governance should be approached, who should be involved in that whole governance process. And then the same for platform, for security, and for operations. So the cloud adoption framework basically, you know, helps people align on certain perspectives. So in these perspectives that are in here, like business perspectives, people perspective, governance perspectives, platform security, operations, et cetera, will help you understand what the needs are that you need to solve for when you move to adopting cloud. So can be useful, can also be pretty big wieldy, like hefty, you know. So all right. So knowledge check here. Which of the AWS cloud adoption frameworks perspective helps customers design, implement, and optimize their solutions based on their business goals and perspectives? Hold on. Design, implement, and optimize solutions. I would think it was A. Hold on, let's go take a look. Huh. It says platform as far as like the answer, but I thought I would have said A, honestly. But yeah, I don't know about that one actually. Based on business goals and perspectives, I'm pretty sure. But maybe it's design, implement, and optimize, right? Because really the business thing really is about alignment. The business perspective is really about aligning the business with IT. The actual implementation piece actually does live in the platform section. So I guess technically that is correct. That's not what I would have gone for though. I would have thought it was business, but the implementation and optimizing, designing piece is actually going to live in the platform section. That's where the solutions architects live. Okay, fair enough. I'll accept that. Okay, so just know the CAF exists. If you're looking for the CAF, by the way, Cloud Adoption Framework. Oh, wait. Oh, Michael. Yeah, so here's the new CAF, right? Version 3.0 just got started, right? So this is the document. It's actually a large PDF file, which you can actually look at. It even takes Firefox a second to download. So this is a white paper, including capabilities, business perspectives, people, governance perspectives, the platform security and operations. So it's a pretty dense, like 25-page document. But there's the abstract. I'm gonna post that in the chat so you can have it. Okay. Let's talk about migration strategies. So there are 6, but technically 4 ways to migrate. I say that because 2 of them do not really involve moving applications to the cloud. So just so you know, 2 of them, retaining and retiring. Retaining is you just keeping the application, you don't do anything with it. Retiring is you just shutting it off. So it has nothing to do with migrating to the cloud. But these other 4, rehosting, replatforming, refactoring, and repurchasing, these are all like core ways to think about migrating applications from one version to the next. Now, I'm going to use some common terms here. Rehosting is commonly referred to as lifting and shifting. You just take the application as is and you stick it on cloud. Now, you're not going to achieve a lot of tangible benefits except some operational offload. So if you got a large legacy, this might, most legacy applications are just rehosted. People don't have time to refactor them. They don't have to replatform them, right? Replatforming, which is the second one, is basically you lift, tinker, and shift So you add the tinkering part, which it means you add a few cloud optimizations. Maybe you move the database into RDS, right? Or maybe you replace the FTP server with S3. That's lift, tinker, and shift. That's replatforming. So not rehosting, which is lift and shift, but replatforming, lift, tinkering, shifting. Now the next two, which is refactoring, re-architecting, repurchasing, are more involved. Refactoring, also known as re-architecting, right, involves you reimagining the application, and you're basically just changing it greatly or rewriting the thing. So you're either redesigning it, re-architecting it, or you are changing the code. You might even be switching code, right? And then repurchasing means that you had a traditional version of the service, maybe like a license for it, and you're going to buy a version of it in cloud. And so you're actually just going to cut over from one service to the next. That's repurchasing, right? So you might switch from an old CRM, for example, to Salesforce.com. Retaining and retiring are exactly what they sound like. Retaining is you're just going to keep it until it dies. Retiring is you're going to retire it. So these R's do show up on occasion, particularly on the architecting exams. They have shown up once or twice for me on the Cloud Practitioner. Rehosting, replatforming, refactoring, re-architecting, or repurchasing. And then the last two, retaining and retiring. Okay, here's a quick question. Which migration strategy involves moving from a traditional license to a software as a service model? That's right, repurchasing. Which of these is the lift, tinker, and shift model? What's the other one that's lift, tinker, and shift? Good. C, replatforming. Which one of these is the most catastrophic in terms of like the amount of change that you're going to execute against an existing application? Yeah, refactoring. It's going to have the most change in it. Well, maybe compared to retiring where you just shut it off, but you're not really changing anything. You're just turning the service off, right? So refactoring is really it. Good. Okay. Now, in terms of migration, I would be completely remiss if I did not actually talk about this random set of services called the Snow family, not to be confused with Jon Snow from Game of Thrones. Maybe he was more competent. Regardless, these are actually really good services. There's three of them. There's the snow cone, the snowball, and the snowmobile. And no, I certainly did not have a hand in naming these things. The snow cone is just a tiny little IoT device. It's got 2 CPUs and about 4 gigs of memory, and I think it has like 8 terabytes of usable storage. This is really just used for the edge. This is like small, rugged. This is an edge device. It can be used as an aggregator or a true edge device. But snow cone is like small and portable. That's what it's used for. The snowball devices are larger, and these are typically used for data transfer. For example, there's a storage version that has 80 terabytes of hard drive space, and I think it's got like a terabyte of like SSD. So 80 terabytes of mechanical, 1 terabyte of solid state, right? And it's used for data transfer. So when you want to migrate things into AWS, when you copy into the storage version of the purple one, the snowball devices, it puts it in S3 when you send it back to AWS. Now there's a compute version, which has got 40 CPUs and 80 gigs of memory. So, sorry, is that right? No. Sorry, there's 2 versions. There's a storage version, which has 80 terabytes of storage space, and it's got like 40 virtual CPUs, which is ridiculous. And then there's a compute optimized version. So these have 2 versions. The compute optimized version only has 42 terabytes of usable disk space, but it's got 52 CPUs and 200 gigs of memory. It's also got like a Tesla GPU and all this other stuff, right? It can also run virtual machines inside of it, like C5s and M5As and whatnot. So just know that the compute optimized device is like a portable VMware system. It's like a portable outpost, whereas the storage version of Snowball is actually used for data transfer. And then just to throw insult to injury, the snowmobile is a truck that drives up to your data center. It's actually pulled by a semi and has an escort, and it runs a cable into your data center, and it will transfer up to 100 petabytes of data per truck. Now, they call this an exabyte scale data transfer service, which is just all pure marketing speak, because can we be very clear about this? It would take you 10 trucks to get to exabyte. So I don't know why they call it an exabyte scale service, because one truck alone does not get you there. Regardless, I guess you could get 10 trucks if you really wanted to, but 100 petabytes of data on a single truck, right? By the way, I was there in 2016 when they drove this on the stage, and then it magically showed up like a transformer inside of the vendor hall for reInvent, which is actually, again, I may mention this going on this week. I gotta tell you, it was weird. I felt like it was like maximum overdrive. I felt like that truck was just following us around. I was like, how did they even squeeze it into the vendor hall? But you know, if you've been to Vegas, you know, everything's tall ceilings there. So bottom line, Snowmobile is for exabyte data transfer. Snowball devices, there's the storage and the compute optimized. The storage version can hold like 73 terabytes of usable space, 80 terabytes technically. The Snow Cone is an edge device, so it's only used for IoT stuff. That does show up on the exam. All right, other things that you need to know about AWS, right? So, you know, AWS wants you to focus more on what the outcomes you're trying to get to and less about like, this is the way we've always done things. Just know that AWS wants to help you solve problems by mainly taking operational overhead off of your plate. So you need to think about things like serverless and highly managed services and artificial intelligence and machine learning, you know, robotics, virtual reality. In other words, Amazon's trying to make complicated things easy. They're trying to democratize it. This includes things like fraud detection, you know, speech to text and text to speech, image recognition. They're basically trying to make it so that machine learning is commoditized. So just you know, AWS is your friend if you're going in this direction. That's what they're trying to share with you. By the way, I suspect most of the announcements from reInvent this week will actually be boring robotics and machine learning improvements, which are actually, I say they're boring, they're actually incredibly useful. But for most of us, we're not connected with that because we're not doing data analysis. But I got to tell you, they really are making it easier to approach some of these cutting edge pieces. I wouldn't be surprised if they released an artificial intelligence framework of some type either. So it's coming. All right, last little piece. Amazon has a well-architected framework, which I mentioned before is a filtering function to help you evaluate about whether your architecture is approaching cloud in the best way possible. There are 5 pillars. There's operational excellence. This includes infrastructure as code, repeatable, collaborative, usable pipelines and spaces, making small batch changes, right? This includes things like security. How do you do defense in depth in all layers? How do you protect data at transit and data at rest? How do you automate security best practices? Excuse me, I have a horrible itch. Reliability, which, you know, how do you recover from disruption? How do you dynamically scale? Like that kind of thing, which also bleeds well into performance, right? How do we, you know, go global in minutes? How do we experiment more often? You know, how do we evolve and use new services that not only give us technical performance, but also business performance, which is what Amazon is driving for. And then last but not least, cost optimization, which is appropriate for it to be at the end. But how do you analyze, attribute, and optimize your spend? That's really what this is about. And are there hard dollars and soft dollars that you can lower the cost for? This is what we're looking for. So 5 pillars: operational excellence, security, reliability, performance efficiency, and cost optimization. These are the 5 pillars. It's funny. I feel like I have to like remember those every time, even though I just rattled them off. Performance efficiency sometimes throws me. Nothing wrong with it, just the word. All right, knowledge check. Which of the cloud adoption framework perspectives helps you structure the selection and implementation of permissions? Well, this one actually is not a trick question because I know we all got fooled last time because I thought for certain it would be business perspective. Turned out to be platform. This one's just straight up honest, right? It's permissions. So which of the frameworks do we think it's, what perspectives do we think it's going to be? Well, it's either going to be operations or security. Let's roll the dice here and say security. There you go. Which of course a bunch of you already did. Good. Which of the strategies below are included in the 6 strategies for application migration? Select 2. I'm just laughing. Some of these options are hilarious. I feel like they should be application migrations, right? Revisiting, remembering, and redeveloping seem like rock solid. You know, remembering we have services. All right, good. I see people putting B&E in there. That's fabulous. Good. So retaining and rehosting, right? So retaining is one of the ones that doesn't really do anything, right? Because you're just going to keep it. What's the like sibling to retaining? If you're not going to keep it, what are you going to do with it? You're going to retire it. Good. Let's revisit this. So we got rehosting, which is really just us lifting and shifting. What are the other 3? Which one is lift, tinker, and shift again? Replatforming. Which one is where we rewrite it? It's really invasive. Refactoring is also known as re-architecting. Good. And then what's the last one that really just has us just cutting over from one service to another service? Repurchase. Perfect. Good job. Okay, that's correct. Okay. What's the capacity of the storage capacity of the AWS Snowmobile? Remember, I made a kind of a big deal out of this because they call it an exabyte service, but it's good. D, petabytes. I'm not making fun of AWS, but I am making fun of AWS, at least their marketing team. Okay, good. What is the storage capacity of the Snowball Edge storage optimized? Remember, this isn't Snowcone. This is Snowball. They're all edge devices, by the way. The storage optimized version I said had 73 terabytes usable, but was advertised as this. Right? You all put C. So you know. I don't have to explain it to you. Good. Okay. Which of these well-architected framework pillars includes the ability to recover from infrastructure or service disruptions? Yeah, reliability, right? Service disruptions. Okay. Okay. So we talked about the cloud adoption framework, which has those 6 perspectives: business, people, governance, operations, security, and platform. We talked about the 6 strategies for migration. We talked about the Snow family, which is not something we often talk about. I mentioned briefly that there is innovation with AWS services, particularly towards ML and AI, right? And robotics. And then the 5 pillars of the well-architected framework are operational excellence, security, reliability, performance efficiency, and cost optimization. Okay, this last and final module is going to cover the AWS Certified Cloud Practitioner exam. But this module is the one that comes with the course, and I have a whole other one that's a lot deeper and broader. So we're going to cover this last little piece, and that's going to be the official end of the course, the official end of the video. And then I'm going to record another video. We're going to take the last like 45 minutes or so We're going to talk about certification. Okay. Get you ready, get you all pumped up, get you a feel for it. Not really going to get you pumped up, but I'm going to get you a feel for it, for how the exam goes. Okay. So let's talk about this last module. In a world where snowmobiles surprise you at every turn, one man was going to talk about certification. All right. All right, so here's some resources according to AWS for preparing for the certification. And then I'm going to give you even more resources that are going to be very specific. That's a step-by-step guide for how you study for the AWS certification for Cloud Practitioner Essential. Okay, so exam details. This is great because some of this we would have covered, and this is going to cover it for us. First of all, about a third of the exam is going to be about technology and services. About a sixth of the exam is going to be about billing. The rest of it, about a quarter, is going to be about cloud concepts and security and compliance. So just know, and by the way, this is all listed on the exam guide on the AWS certification website. And this is going to kind of give you the weighting of each question. Now, it is recommended that you have at least 6 months experience either working with in the tech industry. This is a trivia exam, which is not to trivialize it, which is to say that there is no hands-on components for this exam. There's only one exam in the ecosystem currently that has hands-on, but you should have a basic understanding of things like networking and firewalls and stuff like that, and then have worked around a team for at least 6 months. If you haven't, don't worry, you can make it up with study. Okay, so there's no issue there. Now, know that you do have to complete the exam within 90 minutes. It is a 65 question exam, but there's going to be some fluff questions in there because Amazon likes to test the waters with people at all levels. You need a minimum of 700 to pass. Sometimes that score is higher depending on how your peers are doing who are taking the test. Sometimes it's like 7,200, sorry, 720, 730. But most of the time it's in the 700 range. If you get a 700, you passed, right? The exam has multiple choice and multiple right answers, meaning you might say select 2 or select 3. So the exam is in written form in a bunch of different formats. If you want it in a different language verbally, like your proctor, for example, can only do English and Japanese, which is an interesting combination. If you're a non-native speaker, you can ask for an extension, which I highly recommend that you take if you don't necessarily process things quickly. Not necessarily here for Cloud Practitioner, but definitely for the other exams, I would get a 30-minute extension. If comprehension is, English isn't your first language, just take that extra time. There is no penalty for guessing, by the way. Unanswered questions are scored as incorrect, so there's no reason not to guess. You can flag questions for review before the final submission. So if you are spending too long kind of understanding a question, don't get hung up, just flag it for review and just move on. And you can come back to it at the end before you hit the submit. Now, Amazon has a bunch of technical resources and white papers and support plans and how pricing works and all that. That's great. And you can look at that. Nothing wrong with that. Don't memorize it, but I would skim it at the very least. Just know that I'm also going to give you a guide that is also going to help you study for this as well. So maybe hold off on this unless you really just don't really understand pricing or services. I'm going to talk about in the next section how to sign up for the test and what that's going to look like. And then I believe that all of you are getting access to tutorial dojos, which is the practice exams that we usually use. And we're going to actually share a study guide. So I'm going to send you an email in the next 24 hours that's going to give you a bunch of this information, but we're also going to cover it. You're going to get access to the videos, to all the good stuff, right? So don't worry if you don't have all these links ready to go. All right, so here's a couple of obvious exam strategies to think about. One, make sure you read the full question. Make sure let's see how well you know it by maybe predicting what the answer is before you even look at the answers, because then you can just filter it at that point in time. And then if you're unsure, then go in and just exclude the ones that are incorrect. Do note that both in the in-person and in the proctored exams, you cannot write on a piece of paper. So you're gonna have to kind of mark it in your head. All right, a few questions to test this out. 1, what's the minimum passing score to pass the exam? Good. That is correct. 700 is the right answer. What domains are included on the AWS Certified Cloud Practitioner exam? Select 2. Which domains? Yep. So these domains are included, and these 2 would be security and compliance and billing and pricing. Okay. All right, here's what we're going to do is I'm going to post in an evaluation link and I'm going to stop recording. I'm also going to grant you a 20-minute break so you can fill out the evaluation and just get some like time. When you come back at 4:15, we're going to go through some training material and talk about the program study guide, the practice exams, and how to get some hands-on lab access for free because you're a Booz employee. That's what we're going to do. So first, let me stop sharing and post. Let me grab the link. Where are the evaluations? Here we go. Today's the 29th. All right, so I'm going to push the evaluation in there. This is going to mark the official close of the official AWS portion. Thank you for hanging with me. I know it's a lecture. I know you've been with me, answering questions and hanging out. I appreciate that. Fill out the evaluation about the class, about the Cloud Practitioner course. Just know that this does actually get back to AWS. And then I'm going to pause recording, stop it. We're going to start a whole new set, and we're going to move on to the kind of private experiential piece. Okay. So I'm going to put up a timer. We're going to get 20 minutes. We're going to reconvene at 4:15, and we'll cover all of the deeper training stuff then. Okay. Catch you in a bit.